Have you heard about Planet 9? No, not Pluto. We're talking about something lurking on the outskirts of the solar system. A mysterious planet that exists in our solar system that we haven't yet discovered. We've been looking for it for years, but finally, it seems like scientists found a key to solve this mystery. Planet 9 is a hypothetical planet. Astronomers have been on the hunt for it for quite some time now. But it's so elusive that they've only been able to piece together a few details about its potential characteristics. One thing we do know is that Planet 9 has to be a massive world, possibly up to 10 times the mass of Earth. That's one big planet. It's also thought to be a distant wanderer, hanging out somewhere between Neptune and Pluto. Some scientists think that Planet 9 might actually be a mini Neptune, with a thick, gaseous atmosphere and a rocky core. Others speculate that it could be an icy world with a solid, frozen surface and a thick layer of hydrogen and helium gas. Of course, since we haven't actually found Planet 9 yet, we can't say for sure what it's like. We're not even sure that it even exists. Some say it's just a myth, like the Tooth Fairy or the Easter Bunny, but others are convinced that it's out there somewhere. And at the end of the day, we're not entirely sure if Planet 9 is even a planet. It might be a special kind of black hole or made entirely of dark matter. The search for Planet 9 began in the early 21st century when a group of astronomers realized that something wasn't quite right with the outer reaches of our solar system. They noticed that some distant objects, known as trans-Neptunian objects, were behaving in unexpected ways. Trans-Neptunian objects, or TNOs, are like the cosmic version of those items in the back of your fridge that you forgot about for years. They're small, icy bodies that hang out in the Kuiper Belt, beyond Neptune. So, scientists noticed that these guys started behaving weirdly. At first, they thought it might be a fluke. But as they dug deeper, they began to suspect that there was a ninth planet lurking out there. Why haven't we discovered it yet, you ask? Well, it may be because of Planet 9's weird orbit. All the other 8 planets orbit the Sun in roughly the same plane, which is like a flat disk. However, our hypothetical friend's orbit is different. It might be tilted and move in a different direction compared to the other planets. Its orbit might also be stretched out like an oval, rather than being nearly circular like usual. Because of this, Planet 9 might spend most of its time far from the Sun, like a true introvert. It only comes relatively close to the inner solar system every few thousand years. This would make it super faint and hard to spot, so the only way we may discover it is by studying the gravitational effects it has on our solar system. And this isn't the first time astronomers have gone looking for a new planet. Back in the 19th century, there was a similar hunt for a hypothetical Planet X. But this time, they were armed with much better technology and a much better sense of humor. They began calling their elusive quarry Planet 9, which was much catchier than Planet X. They even came up with a hashtag for the search, Pluto Lives. It was a reference to the fact that Pluto had been kicked from the planet gang and some astronomers were eager to find a new planet to take its place. But the search for Planet 9 has been no easy task. It's like trying to find a lost sock in the laundry basket the size of a football stadium. It's so far away and so faint that even the most powerful telescopes can't see it. Instead, astronomers have had to rely on indirect evidence, like the strange orbits of TNOs, to try to figure out where it might be. Some scientists have even supposed that it might be a wandering rogue planet, which would explain why it's so hard to find. But they haven't given up hope. Till this day, they're scouring the skies using all sorts of high-tech telescopes and fancy algorithms to try and spot this elusive planet. And fear not, dear curious human, because it looks like after so many years of research, we may have finally found the key to solve this mystery. Astronomer Man Ho Chan from Hong Kong has a theory. He believes that Planet 9 could have a bevy of moons. That's right, not only is it a giant planet hiding out in the depths of space, but it's also a bit of a hoarder. Moons are all the rage in the outer solar system. In fact, almost every planet here has at least one moon, except for Mercury and Venus. Earth has just one, which is kind of sad if you think about it. Even non-planetary bodies like Pluto have at least a couple of moons. A bit unfair, isn't it? Anyway, taking this into account, let's go moon picking with Planet 9. The region between the rock-filled Kuiper Belt and the rock-filled Oort cloud, where this planet is predicted to be, should be ripe for the picking. Chan made some calculations and determined that it would be stranger if the elusive planet didn't have any satellites. According to his calculations, an object the mass of Planet 9 should capture at least 20 TNOs as large as almost 90 miles across. It's like our mysterious planet is playing cosmic Pokemon with these guys. So, what if Planet 9 has moons? Would that make any difference? Kinda yes. They could give us some indirect clues to finally locate this mysterious planet. Now, you might be thinking, how in the cosmos can we possibly spot these teeny tiny moons? It's not like they're going to wave a giant flag or blast some Beyoncé tunes to get our attention. Well, apparently the key lies in something called tidal heating. Tidal heating might sound like a new workout trend, but it's a real scientific phenomenon. It happens when two celestial bodies are close together. You see, tides aren't just about the rise and fall of the ocean, they're also the result of gravity pulling unevenly on a planet or moon. When a planet and a moon are close enough to each other, their gravity pulls on each other, creating a bit of a football shape. And as these celestial bodies move around each other, they shift shape and generate friction inside, which produces heat. Wow, who knew that Planet 9 could have a workout routine? Perhaps we should start calling it Gym Planet instead. Anyway, if Planet 9 has any moons, the gravitational pull from these moons would cause it to change shape constantly, generating heat in the process. And we might be able to detect this mysterious planet through the heat produced by those moons, even though it gives off no other signals. Now, before you get too excited, finding them won't be a walk in the park. They're incredibly small and would be very far away from us. But hey, nothing worth discovering ever came easy, right? Scientists are optimistic that with the right technology, they can spot this telltale sign. It will be easier for us to spot them with fancy instruments like modern telescopes. Talk about cool friends to have, right? Sure, the process of finding it may be difficult and time-consuming, but the potential payoff is huge. Finding this planet could explain a lot of the strange behavior observed in TNOs, the Kuiper Belt, and beyond. As we've already mentioned, they've been acting super weird lately, tilting and aligning in suspicious ways. If this planet doesn't actually exist, we have yet to explain what is the reason for this strange behavior. In any case, the search for Planet 9 is one of the most exciting and intriguing quests in modern astronomy. It's like a cosmic scavenger hunt, and everyone's invited to join in on the fun. So, grab your telescopes and let's go planet hunting. Who knows, maybe we'll find it sooner than we think. Look at this fascinating planet. It looks as if it's burning. It must be hotter on its surface than in the middle of Death Valley. The ground is parched, cut by giant cracks. There's not a drop of water in this boiling world. Now, it's the same planet, but it looks like a totally different place. Everything is frozen. The temperatures are so low, there isn't even a tiniest chance that life could survive on this planet. This bizarre world is called HD 20794d, and it's located 19.7 light-years away from Earth, in the constellation Eridanus. This planet is a super-Earth. This term means that it is larger than Earth but smaller than such ice giants as Neptune. What makes this planet especially interesting is its unusual orbit, which moves it in and out of its star's habitable zone, the region where temperatures might allow liquid water to exist. Now, we haven't seen this unusual planet directly. Astronomers detected it by measuring tiny wobbles in its star using two powerful instruments, espresso and HARPS, located at telescopes in Chile. These instruments measure radial velocity, which is the small movement a star makes as a planet's gravity tugs on it. The larger the wobble, the more massive the planet. Later, astronomers analyzed the data and figured out that the planet in question has a mass around 6 times greater than Earth's. It orbits a star, which is slightly smaller and dimmer than our Sun. What makes this star unique is that it is bright enough to be seen with the unaided eye, unlike many other stars that host exoplanets. You won't be able to see them without a telescope. The star system has been observed for over 20 years. Astronomers have long suspected it had multiple planets. In 2011, scientists discovered 2 other super-Earths orbiting the star every 18.3 and 89.6 days, respectively. For some time, researchers thought they had found a third planet with an orbital period of 40 days. Later, they realized they had made a mistake. But recently, after reanalyzing years of data, astronomers have confirmed that the third planet does exist, and it's our extreme HD 20794d. A researcher from the University of Oxford played a key role in identifying the planet. He used a special computer algorithm called Yarara to separate the planet's weak signal from the background noise. It helped him confirm that the planet truly existed and was pretty unique. Unlike the planets in our solar system, which have mostly circular orbits, the newly discovered one follows a highly elliptical, stretched-out orbit. It takes 647 days to complete one trip around its star. That's just 40 days shorter than Mars's orbit around the Sun. At its furthest point, the planet is twice the Earth-Sun distance, which makes it an icy world far outside the habitable zone. At its closest point, it moves inward to 0.75 AU, where it enters the habitable zone, where liquid water might exist. This extreme movement creates truly bizarre seasons. For some part of its orbit, HD 20794d is frozen, like an icy wasteland. As it approaches its star, temperatures rise and ice likely melts, forming temporary oceans. The planet then experiences a short, scorching summer. It is so hot that the water on its surface might evaporate into the atmosphere. Shortly after, the planet moves away again. It triggers a gloomy fall with rains, followed by a deep freeze in winter. In other words, the planet switches between extreme cold and intense heat, which makes it a very unpredictable place for life. If any life forms exist there, they certainly need to adapt to dramatic changes in temperature and environment. Why does the planet follow such a mind-boggling orbit? It might be a leftover effect from events billions of years ago, when the planetary system was still forming. At some point, another large planet may have disturbed the orbit of our extraordinary friend. Another possible explanation is that a giant planet once existed in the system, and its gravity pushed HD 20794d into an elongated path. Later, this giant planet may have been ejected from the system, leaving the smaller planet in its current orbit. This theory makes sense because the 2 other planets in the system, B and C, have more normal circular orbits. The discovery of this planet is so exciting because it challenges what we know about habitable planets. Most planets in the habitable zone stay there permanently, but HD 20794d only passes through it. Scientists want to know if such a planet could still support life, even briefly. So future telescopes will study the atmosphere of this planet, looking for signs of water, gases, or even life. Another super-Earth that might have the right conditions for life orbits a star 137 light-years away. In space terms, this is considered relatively close. A light year is around 6 trillion miles. The planet is called TOI 715b, and it's about 1.5 times the size of Earth. Unlike HD 20794d, it's permanently located in the habitable zone. Look, that's what astronomers think the planet might look like. TOI 715b orbits its star very quickly, completing a full orbit in just 19 days. But even though it's close to its star, it may not be extremely hot, all because its star is a red dwarf. That's a type of star that is smaller and cooler than our Sun. This means TOI 715b could have a milder temperature compared to other exoplanets that orbit closer to hotter stars. NASA discovered the planet using the Transiting Exoplanet Survey satellite. This space telescope finds planets by watching for small dips in a star's brightness, which happen when a planet passes in front of it. Since red dwarfs are smaller and dimmer than the Sun, planets passing in front of them are easier to detect. Astronomers are planning to study the planet further using the James Webb Space Telescope. This powerful telescope, located 1 million miles away from Earth, can analyze the atmospheres of distant planets. If TOI 715b has an atmosphere, JWST could help scientists determine what gases are present in it and whether such conditions could support liquid water or even life. One more promising world for our search for extraterrestrial life is an extremely dense super-Earth in the K2360 system. An international team of researchers from Japan and Europe has discovered this remarkable multi-planet system orbiting a Sun-like star located 750 light-years away. This system has 2 planets, including one of the densest rocky planets ever found. The K2360b is a rocky super-Earth, about 1.6 times the size of Earth, but with a mass 7.7 times greater. This makes it as dense as lead. The planet orbits its star incredibly fast, completing one full orbit in just 21 hours. It's the densest known ultra-short period planet with well-measured properties. As for its sibling, this is a much larger outer planet with at least 15 Earth masses. It takes 9.8 days to orbit its star. Sadly, since it does not pass in front of its star from our viewpoint, scientists cannot determine its exact size. The unusually dense planet might be the core of a much larger planet. Over time, intense radiation from its parent star may have blown away its outer layers, leaving behind only its dense, rocky core. So, in fact, this planet could show us what might happen to some planets that are too close to their stars. Astronomers think that the planet may have moved inward over time due to interactions with its larger companion planet. One possibility is high eccentricity migration, where a planet's orbit becomes highly stretched out due to gravitational interactions before gradually becoming more circular near the star. Another theory is that the planet's spin and axial tilt can cause its orbit to become more circular. Such planets are rare, and finding one with a massive outer companion can help scientists refine their theories about how planets form and evolve in extreme environments. With its help, we might also understand how rocky planets evolve and what happens to planets that get too close to their stars.
Guess what? The universe can get actual scars, just like when you fall off a bike. Well, here's why. Before the Big Bang, the universe was extremely hot, dense, and full of energy, and it seemed like everything was going well, until that all changed about 13.8 billion years ago. Then the universe exploded. After the blast, it expanded incredibly quickly. Our human brain can't even perceive how fast that expansion was. Sometime later, the universe started cooling down. As it did, giant, terrifying scars cutting through space-time appeared all over the place. And if we study these scars well, we can even get insight into time travel. These days, we call these scars cosmic strings. They're like stretch marks that appear when the skin expands too quickly. Or we could also compare them to cracks that form in the ice when it freezes. These strings are likely very thin, about the size of a proton, a positively charged subatomic particle. Yes, subatomic means smaller than an atom. The strings are also extremely dense and can stretch for light years. Now, imagine these cosmic scars floating through space, not interacting much with their surroundings. When two cosmic strings pass each other, they could warp space-time in such a way that it creates a time machine. If you were to travel along a certain path around these strings, you would end up returning to your starting point at an earlier time, which is traveling back in time. Now, let's admit it, this idea sounds like something from science fiction, but it's supported by cosmic string theory, and the math behind it seems to work. Unfortunately, no one has observed cosmic strings yet, so for now, it's still a theory. In 1991, one physicist proposed an idea for how cosmic strings could enable time travel. If two infinite cosmic strings passed each other in parallel, they would warp space-time, creating a time loop. This loop would allow someone to travel back in time. Even better, this idea doesn't contradict Einstein's theory of general relativity, which suggests that large objects can bend space and time. These bends in space-time could allow a shortcut through time. His now well-known concept of closed time loops also helps explain how wormholes might work. So, a wormhole is basically a theoretical tunnel connecting one place in space to another. Some people believe that by using such tunnels, we could create shortcuts for incredibly long journeys through the universe, which would allow us to visit other star systems and galaxies. So, let's say you manage to create a wormhole and even accelerate one of its ends to near the speed of light, and then you send it back to where it came from. Well, at that moment, those two ends are not synced anymore. One is in the past, while the other is in the future. And if you somehow manage to walk between them, you'd be time traveling. You could do something similar by placing one end of the wormhole near a powerful gravitational field, like a black hole, and keeping the other side near a weaker gravitational force. This way, according to the theory of relativity, time would pass more slowly nearer to the strong gravity side, and it would allow a particle or another chunk of mass to remain in the past relative to the other side of the wormhole. At the same time, if you decided to create a wormhole, you'd have to keep in mind that they are super dangerous. They might collapse all of a sudden. They're likely to be highly radioactive, or you could come into contact with toxic exotic matter inside. But let's get back to the math behind the cosmic string time machine idea. Admittedly, it is solid, but it doesn't mean such a time machine is possible yet. To use this way of time travel, we'd need to reach near light speed, and it might be impossible. According to Einstein's relativity, the faster an object travels, the more energy it needs to continue speeding up. In other words, we don't yet have the technology or energy sources to accelerate a spacecraft to these speeds. The idea of two infinite cosmic strings is also questionable because we can't create something that's infinitely long. So, while this time travel model is mathematically sound, the infinite nature of the strings would make this exact model impractical. At the same time, some scientists still believe that cosmic strings are a better possibility than most other models, like wormholes. In any case, before we can start considering time travel, we need to discover cosmic strings. Luckily, there's a group of astronomers working to detect low-frequency gravitational waves by measuring signals from a type of star called a pulsar. Now, pulsars send out regular pulses of radio waves, and by measuring small changes in the timing of these pulses, scientists can detect subtle shifts in space-time. Those changes are caused by gravitational waves, which are ripples in space-time. Now, so far, we've only detected gravitational waves coming from black holes. But in 2020, there was one strange signal that didn't look like it came from black holes. It could be coming from cosmic strings. And here, we need to mention string theory. According to it, the universe is made up of more than just the four dimensions of space-time. There are additional dimensions that are hidden from us. Plus, The basic building blocks of the universe aren't particles, but tiny vibrating strings. These strings can vibrate at different frequencies to create different fundamental particles. These strings, from string theory, could have stretched out during the early universe and become the very cosmic strings we've discussed. In the coming years, we might get more information about them from a space-based gravitational wave telescope called LISA. It's supposed to launch in 2035. But if the signals picked up in 2020 really came from cosmic strings, it could mean a huge breakthrough in physics. In this case, string theory would become the right framework for understanding the universe. It would completely change the way we think about the building blocks of our reality. On the other hand, even if the signals don't turn out to be from cosmic strings, this discovery would still be important. It would give scientists more information on what cosmic string signals might look like in the future. And while we're not yet at the point of time travel, the discovery of cosmic strings could take us one step closer to understanding the mysteries of the universe and maybe even the possibility of traveling through time. Now, time travel is a popular theme in science fiction, but in fact, moving forward in time happens naturally. Right now, you are traveling into the future at a steady rate of 1 second per second. However, scientists have discovered that this rate can change depending on speed and gravity. Einstein's special theory of relativity explains that time slows down as an object moves faster. The closer you get to the speed of light, the more slowly time passes for you, compared to someone who isn't moving at all. The general theory of relativity adds another factor: gravity. The stronger the gravitational pull, the more slowly time moves. Near massive objects, such as the surface of a neutron star, black hole, or even Earth, time runs more slowly than it does far away from these space objects. If someone were to stay near the edge of a black hole, where gravity is incredibly strong, only a few hours might pass for them, while thousands of years would go by for people on Earth. If they returned, they would have effectively traveled into the future. This is a real and scientifically proven effect. A real-life example of time travel, though on a tiny scale, can be witnessed in space missions. For example, this cosmonaut spent a total of 748 days aboard the space station Mir during 3 separate missions. Because Mir was moving at high speeds relative to Earth, it experienced time dilation. As a result, he aged 0.02 of a second less than had he stayed on the ground. Now, this difference may seem tiny, but it shows that time moves differently depending on speed and location. But while traveling to the future is scientifically possible, traveling to the past is much more complicated and controversial, and leads to logical paradoxes. Imagine you throw a billiard ball into a time machine. It travels to the past and collides with its earlier self. This prevents the ball from ever entering the time machine in the first place. A contradiction. Scientists have found an invisible star at the Milky Way center, a star that helped our galaxy be born. 26,000 light-years away, in the galactic center, a massive, invisible object started spreading everywhere, and you don't even know that you're breathing it right now. It all started in the 70s, when an astronomer named Vera Rubin was studying the Andromeda Galaxy. She decided to check whether stars move in a predictable way. Now let's say you're spinning a ball on a string around yourself. The closer the ball is to you, the faster it moves in a tight circle. But if you let the string out longer, the ball moves more slowly in a bigger loop. That's how gravity works. And the same goes for planets. The closer ones, like Mercury, zoom around quickly, completing their orbits in months. The far ones, like Neptune and Saturn, take their time, decades, to make one rotation. The stars themselves should orbit the centers of their galaxies the same way. The closer ones move fast, the farther ones are slower, right? But when Vera measured the speeds, she saw something impossible. They weren't slowing down. The faraway stars were moving just as fast as the ones near the center. By all logic, the galaxies should have torn themselves apart, but they didn't. And that meant something was holding them together, something undetectable. Some massive, invisible object in the galactic center warping reality without ever revealing itself. So she checked over and over with different galaxies. This wasn't a fluke, it was happening everywhere. Rubin had accidentally uncovered proof that galaxies were drowning in something far heavier than all the stars, planets, and gas in our entire universe combined. It was holding us with ghostly hands. Astronomers called it dark matter because it doesn't glow, doesn't reflect light, doesn't seem to interact with anything at all. It's just there. But all the calculations show us that it exists, and not merely exists, but makes up 85% of all the mass in the universe. We know that it sculpted galaxies. Without it, the world as we know it wouldn't exist. And yet, just like with an invisible star scientists found at the Milky Way center, the only way to detect it was through gravity. So how do you find something that refuses to be found? Recently, scientists discovered there might be an invisible star at the Milky Way center, and this fascinating discovery might finally help us understand what dark matter looks like. They began looking for dark matter's fingerprints, any signs of its presence anywhere. They studied how galaxies moved and smashed particles together in giant machines, hoping to create tiny bits of dark matter in the lab. This didn't really lead to anything. They didn't even know what to look for. Is dark matter even made of particles? There was a theory that suggested that it's made of ghostly particles that barely touch anything, or even weirder ones that might flicker in and out of existence in the blink of an eye. There was a problem, though. If dark matter really worked like that, then the centers of galaxies should be packed tight. Tons of matter would be crammed into a tiny space. But in our universe, galactic cores seem strangely soft, spread out, almost gentle. A new theory emerged, and it was wild. What if the dark matter at the heart of galaxies isn't made of heavy particles at all? What if it's made of something so delicate that it behaves more like a strand of hair? These hairs could be made of something incredibly light, lighter than anything we've ever seen, and billions of times smaller than a neutrino, which is already the lightest known particle. They called this idea fuzzy dark matter, and it might change everything we thought we knew about the universe. A team of astrophysicists wanted to test this idea, so they ran a simulation, creating a simple model of a galaxy with two main ingredients: a whole lot of fuzzy dark matter and a little bit of gas, the same kind of gas that forms the stars we can see. They pressed start and just let the system evolve by itself, watching how the two would interact. At first everything was pure chaos, but then the fuzzy dark matter started to gather. It pulled itself together, forming a massive invisible object near a galactic center. The gas followed, spreading throughout this ghostly mass, mixing with it and glowing faintly. And then it suddenly formed something incredible: dark stars. Not typical stars like our sun, blazing with heat and light. Instead, it's enormous, massive, invisible objects, a hybrid of two different kinds of matter. We've never seen anything like this before. An object that would stretch across thousands of light years, and yet they'd be almost weightless, more like cosmic puffy clouds than anything else. Scientists called them Fermion boson stars. Finally, this dark matter thing is starting to make sense. The core of this strange invisible star would have just the right density, not too dense, not too loose. And it looked exactly like what astronomers actually see in real galaxies. If it's confirmed, then it would finally explain how dark matter behaves and works. And if they're right, then every galaxy in the universe could be tied to one of those vast unseen giants. The Milky Way hidden star might be one of them, shaping our galaxy in ways we never realized. What's wild is that this stuff wouldn't behave like normal matter. It wouldn't form anything solid. Instead, it would be more like a complex, ever-moving web of filaments or hairs. This also means that Earth might be completely surrounded by it. Dark matter still follows the rules of gravity. As it moves past planets and stars, gravity pulls it into focused streams, so it's both hugging and passing through our planet, wobbling consistently. If we could see them, they might look like glowing invisible threads everywhere. and they'd pierce right through the planet, stretching far into space. But this is only the beginning. Now scientists need to refine their models, make them even more detailed, and compare their predictions to real galaxies. But this dark star discovery in the galaxy's center isn't our only clue. Luckily, the universe has given us a way to look for that fingerprint: gravitational lensing. When light from a faraway galaxy travels toward us, it sometimes passes by another massive galaxy on the way, or other massive objects with crazy gravity. Instead of continuing in a straight stream, light actually gets bent around the massive object because of that gravity. And when it finally reaches us, it creates a distorted and magnified version of the original galaxy. Basically, it's like looking through a piece of curved glass. If dark matter is fuzzy, then it should leave a strange pattern on these distorted images. Things should be a bit wavy and unclear. Scientists needed the perfect object to study this, and they found one. A faraway galaxy whose light was bent by gravity, creating a strange stretched-out image. They used super powerful radio telescopes, connected them all over the world, and turned them into one giant telescope as big as the Earth itself. With this, they could zoom in so much that they could see details of that galaxy as tiny as a grain of sand on the moon. Then they ran a huge experiment. They created their own fake versions of this picture, simulations with various sizes of fuzzy dark matter particles. And at a certain point, they found the perfect match. This helped us calculate the exact mass of dark matter particles before we even detected them. And the clues are leading us right to our own galaxy. It seems like densest parts of these hairs, the roots, might be super close in the cosmic scale, just tens of thousands of miles from Earth. That's close enough for a space probe to reach. Now that scientists have found this invisible star at the Milky Way center, we just need to study it up close, send a mission to one of these roots, and then we might finally crack the greatest space mystery of all.
NASA sent a spacecraft right into the Sun. It's the fastest human-made object ever, and could cover the distance from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe's mission is to study our star's dangerous behavior. Scientists warn that massive solar storms are inevitable, and the consequences could be catastrophic for our planet. The spacecraft got 7 times closer to the Sun than any other probe ever did. It managed to do so during its 20-second flyby to the star since its launch in 2018. Because our star is so massive, its gravity is really strong, like a giant magnet. As the probe flies around the Sun, it uses gravity to go faster and faster and eventually picks up that crazy speed. As it got closer and closer to the Sun's corona, which is its outer atmosphere, the probe had to survive temperatures of 2,552 degrees Fahrenheit. That's hot enough to melt many metals. It was protected from that heat and radiation by a 4.5-inch thick carbon shield. It kept the tools inside the probe safe and running at around room temperature. The scientists went to all this effort because they're hoping to solve a big mystery about the Sun that's been puzzling them for ages. The surface of our main star is already super hot, but as you move closer out to the corona, the temperature shoots up to millions of degrees. And it doesn't make any sense because it's farther away from the Sun. So maybe we could finally get some answers about this heat phenomenon. The mission is also going to help us understand something called solar wind. The Sun is constantly shooting out tiny bits of energy and charged particles into space, like a never-ending breeze of electricity. When this solar wind hits Earth, it can create amazing light shows in the sky called auroras. The more active the Sun is, the farther south you can see auroras. Our star follows natural cycles that last about 11 years. The activity goes from low to high and back down to low. Right now, we're in the solar maximum, the peak of the activity cycle. That's why we've spotted beautiful auroras in the most unexpected places in 2024. The downside to it is that the sun's activity can send out bursts of energy and charged particles that can mess up things like radios, satellites, and even GPS. It can be dangerous, especially for astronauts out in space who aren't as protected as we are here on Earth. Humans wouldn't feel the compression of the planet's electromagnetic field because of all the extra radiation, but power grids are really sensitive to it. If we don't act fast, when it happens, the influx of energy will go into power transformers all over the world, disrupt them, and leave big areas without electricity. If this happens during a hurricane or a tornado, when communication is already super important, it could make it much harder for emergency services to communicate and save lives. That's why it's so important to learn to predict this space weather. It's tricky because, unlike most disasters, like earthquakes, floods, and volcanoes, it doesn't leave behind any kind of physical evidence. The only big solar storms we really know about happened in 1859 and 1921. The first one, called the Carrington event, was so wild that it made sparks fly from telegraph wires. The auroras were seen all the way near the equator. Scientists back then were using a special kind of paper that reacted to light to record solar activity. During the Carrington event, the reading from the sun went off the page, literally. Whatever was happening, it was so extreme that we still don't fully understand it. Then, there was the New York Railroad Storm of 1921. It was powerful enough to knock out telegraph systems across the US, Europe, and the Southern Hemisphere. The storm boosted radio transmissions for a bit, making them travel farther than usual. But back then, there weren't nearly as many radios, so it wasn't super helpful. The bigger problem was the electrical grid in the US, which was heavily damaged. Back in 1859 and 1921, people weren't as dependent on tech as we are now. If a storm like that hits today, the consequences could be way more catastrophic. Scientists from New Zealand who study space weather are working on simulations trying to prevent disasters from happening. They say one of the possible options to do it is to study other suns like ours elsewhere in space. If we get data from thousands of stars, not just one, the picture for analysis would be more complete. So far, scientists have launched or plan to launch several other missions in addition to the Parker Solar Probe. Meanwhile, NASA is working on another mission, launching Endurance, robotic moon machinery on steroids. Its main mission will be to collect samples from key lunar locations that will later be retrieved by astronauts from the Artemis program. These samples are spread across the largest impact basin on the Moon, separated by hundreds of miles. To do it, Endurance will have to be way more advanced than Perseverance, NASA's current most cutting-edge rover. Endurance will drive roughly 100 times further, drive 10 times faster, and collect roughly 200 times more sample mass. Endurance would also be the first planetary rover to drive at night. And because it will be on the far side of the Moon with limited communication to Earth and surface data, it will have to drive autonomously between sample locks and make its own decisions in tough conditions. When it reaches its destination, it's going to switch to a more classic way of doing things. Scientists back on Earth will get involved directly, guiding the rover to explore the sites and collect samples. The teams on Earth will also keep an eye on how the rover is doing by monitoring its telemetry, which is the data it sends back, like its health stats. If they spot any signs that a part is wearing out or something isn't working quite right, they'll tweak the plan to keep things running smoothly. All this will cost huge amounts of money, probably way more than the Viper moon mission that was cancelled after NASA had spent around $450 million on it. While Endurance is in the planning stage, the Blue Ghost lunar lander is already on its way to the Moon. Its main mission is research. It will spend 25 days in Earth's orbit, taking measurements and waiting for the right time to fling itself to the Moon. After 4 days in transit, Blue Ghost will hang out in lunar orbit for another 16 days to collect more data. Then it will descend to one of the largest basins on the Moon and spend one lunar day there. It will measure subsurface thermal data, radiation levels, and other important data. At the end of its mission, Blue Ghost will take some final pictures of the lunar sunset. It isn't designed to return back to our planet, so when the night falls, it will do some final work and go offline for good. NASA chose the team of University of Florida aerospace engineers to work on another innovative space project. It will cost $12 million, and its goal will be to improve the way we track changes in tectonic plates and oceans on Earth from space. It will use state-of-the-art sensors that will measure even the tiniest gravitational changes. The data it gets will help scientists monitor droughts, assess groundwater reserves, and better understand changes in sea levels. They expect to launch it around 2027 aboard a SpaceX Falcon 9 rocket.
This signal had been traveling through space for 200 million years, and now, when it finally reached Earth, it brought a fascinating story with itself. It might even help us solve an 18-year-long mystery. We caught this one in 2022. It was such an intense burst of radio waves. Even though it lit up for a fraction of a second, it outshined entire galaxies. At first, this signal hasn't caught attention because we've seen similar things before. It was a fast radio burst, or FRB for short. These guys have been a mystery for years now, all because we have no idea where they come from. Now, FRBs are brief booms of energy coming to us from all over outer space. They're barely catchable, lasting up to 3 seconds. But they're also very hard to miss because their power is absolutely unimaginable. One little burst can release as much energy as the sun does in an entire day. They've been a puzzle for us ever since 2007. We've caught over 1,000 of those signals from literally everywhere, from our own galaxy to places as far as 8 billion light-years away. And none of them revealed where they're coming from or what they mean. At least we know they're not from extraterrestrial creatures. They have to be coming from something that happens nearly constantly, and this recent signal might finally help us learn the truth. It lasted about 2 milliseconds, and it wasn't particularly bright. But when researchers took a closer look, they realized they can actually finally track this one. They got to it immediately. They saw that the burst came from a galaxy about 200 million light-years away. In other words, this is exactly how long these radio waves have been traveling to us. The signal flickered in a weird pattern. This is what we call a scintillation. When light or radio waves travel to us, they can stumble upon unexpected crazy clouds of gas. The particles in light waves start bouncing off this gas, which disturbs the signal a little bit. So when we received it, it was a bit weird and distorted, kind of like me. But this exact cloud was what helped us locate where exactly this signal came from. Turns out, it came from a neutron star. Now these are some fascinating guys. They're the remnants of stars that live fast and burn bright. When a powerful star like this, much larger than our Earth, runs out of fuel, it can no longer support its weight. So it goes away with an insane spectacle called a supernova. During its last moments, its core collapses under its own super-strong gravity, and this creates one of the densest objects in the universe. Again, a lot like me. Hey, what can I say? For curiosity, let's compare it to osmium, the most dense element on our planet. If you had a small cube of osmium, it would weigh around 0.8 pounds. That's already pretty heavy, and it means that 1 cubic foot of osmium would weigh a shocking 1,410 pounds. That's like an average cow. Now, just try to guess how much a small cube of neutron star would weigh. Wrong. It would be a horrifying 7 billion tons per one little cube. Don't even think about holding it in your hand. That thing would warp the fabric of reality around it. It's kind of like trying to imagine Mount Everest being squeezed into a tiny ball. Hard to even imagine. So even though they're so heavy, these stars are surprisingly small, only about 6 miles in radius. That's like a city size, and it would still weigh more than our sun. But if that's not enough horror for you, The neutron star we're talking about wasn't your regular one, it was a magnetar. Now, magnetar is a rare type of neutron star. When a neutron star is born, there's only a 10% chance that it will become one of those guys. It can happen if, while the star is collapsing, its magnetic field grows wildly stronger. The spin is rapid, the insides are going wild, and boom, we've got a magnetic field a trillion times stronger than Earth's. More than that, these are among the most extreme magnetic fields in the entire universe. They can literally rip atoms apart. Which is exactly what they do. They just rip everything apart. So they end up being surrounded by a super hot, electrically charged soup of particles called plasma. The magnetic field is going wacky, twisting, and bending the plasma as it sees fit. And this all just ends up as an ultra-hot party. Everyone is constantly colliding, scattering, and being absorbed. Not the best place for a hangout. Now, back to our main character. The magnetar in our story also had a plasma soup and a terrifying invisible field surrounding it. And this is exactly where that mysterious signal came from. A signal was born somewhere in that place, at a distance of 6,200 miles away from the magnetar. Sounds like a lot, but that's a distance shorter than a flight from New York to Singapore. But this is very weird, because how can a radio burst even escape a place like that? Now, usually they'd end up being blocked or absorbed. Most often, radio waves end up hanging out there like in a cage. This one, however, managed to break free somehow, which means that something happened that punched through the plasma. Energy somehow goes goofy, twists and reshapes itself in such ways that it starts releasing radio waves. Now, in any case, this means that FRBs most likely come from neutron stars and various types, like magnetars or pulsars. Recently, astronomers made a new amazing telescope called CHIME, the Canadian Hydrogen Intensity Mapping Experiment, a mouthful. This one detects FRBs literally every day. FRBs are full of surprises in general. In the same year, we discovered an FRB with periodic peaks lasting over 3 seconds, much longer than typical bursts. This one could also come from a neutron star. But if it was just neutron stars, we wouldn't probably receive them all that often. It looks like these signals are very diverse and might actually be born from all sorts of places, like near black holes. So there are some other theories about their origin. For example, they could come from two stars smashing into each other. What could be more epic than that? A collision of two stars would release unimaginable energy, and they destroy each other completely. Uh-oh. Some astronomers think they could explain FRBs, but of course, that's not something that happens often at all. Also, FRBs sometimes repeat. Most of them flash once and disappear, but sometimes they almost flicker like the one we discussed. Some of them even follow very precise patterns. For example, one well-known repeater follows a 16-day cycle. It goes crazy for about 4 days and then goes quiet for 12 days before starting again. This one is hard to explain even with neutron stars. There has to be some unique astrophysical mechanism at play. Maybe something that orbits something else. But anyway, a star's collision would only explain signals that flash once and never again. Another possibility is the blitzar. It's a goofy name for a very dramatic idea. A neutron star turning into a black hole. Once again, an event like that unleashes a huge burst of radio waves. But, again, an occasion like that would be incredibly rare, and the signals aren't supposed to repeat. Black holes themselves are a pretty good option, though. They're central to many FRB theories. Could these bursts come from a neutron star falling into a black hole? Or from a collapsing black hole itself? Maybe even dark matter interacting with a black hole? Hey, who knows? Let's just throw all the ideas in there. Of course, the thing that everyone's most excited about is extraterrestrial civilization. Maybe not all of these bursts, but at least some of them could be signals from our intelligent neighbors. But like we said, that's very unlikely, considering that the signals come from all over the sky and many different distances. Also, almost all of them are the same, and that would be super hard and weird from an intelligent civilization to try and reproduce. Though who knows what else we might discover in the future.
Scientists think there might be a huge onion chilling somewhere out there in space. Not an actual one, but it's something even crazier. These are stars stacked inside each other, layer upon layer. These fascinating objects, called Gravastars, could even be cousins of black holes. But most importantly, they might hold the key to understanding some of the most mysterious puzzles in the universe, dark energy, and even other dimensions. Let's start with gravity. Over a century ago, Albert Einstein helped us understand how gravity works. Turns out, it's not just something that pulls things on Earth and makes apples fall on Newton's head. It's much wilder. It's about warping the very fabric of existence itself. Let's say you toss a heavy ball, like a bowling ball, onto the middle of your bed. What happens to the sheets? They dip, don't they? They stretch and sag around the ball. Now, if you roll a smaller ball, like a marble, across the bed, it doesn't move in a straight line anymore. Instead, it starts circling the heavy ball, rolling closer and closer as if the heavy ball is pulling it in. That's gravity. But instead of bed sheets, we're talking about the fabric of space and time itself, or space-time for short. Heavy objects like planets and stars make dents in space-time, and moons, planets, or even light move along these dents. Gravity is the curve that tells them where to go. In that case, you can guess that black holes are like the ultimate heavy balls. The heaviest, in fact. The gravity is so strong, it shrinks them, making them smaller and smaller. So tiny, they could fit in the palm of your hand, but with the mass of several suns. Some of them are like holding over 40 billion solar masses in your palm. It's ridiculous, but they basically create a bottomless pit in space-time with insane gravity. This area around them, called the event horizon, is the most horrifying thing ever. It's a point of no return. Once something gets there, it can never escape being eaten. When something falls past the event horizon, it can't climb back out, not even light. Which is why they seem like, well, black holes. But gravastars, they're something much weirder. Just like black holes, they're probably very compact. But instead of being tiny pits of endless gravity, they might have something wild at their core: dark energy. This is one of the universe's biggest mysteries. Dark energy, this invisible, mysterious something that seems to be pushing the universe apart faster and faster. It's like a polar opposite of gravity. While gravity tries to pull things together to slow down the expansion of the universe, dark energy is trying its hardest to make our world even bigger. Luckily, dark energy has been winning so far. Otherwise, we'd all be in some deep pit. But if we can explain the gravity with balls, then what exactly is dark energy? A force, an energy field, something else? We have no idea. Scientists have seen its effects. They know that it's incredibly spread out everywhere, but they can't tell you what that thing even is. But if it's trapped inside of gravastars, maybe we'll finally discover the truth. This name stands for gravitational condensate stars. Gravastars were dreamed up by two physics professors, Paul Mazur and Emil Mottola, in 2006. They tried to think, what else besides black holes could happen when a massive star collapses on itself? That's how they created this alternative. Think of it this way. Gravity pulls everything inward, making super heavy objects like stars shrink in size. The more the star shrinks, the denser it gets, and its gravity grows stronger. After some point, it can cross a critical threshold and become a black hole. But what if there was dark energy inside to counteract this? At the core of a gravastar, there could be a region filled with false vacuum or dark energy. This energy would push outward, fighting the gravity. It's like the unstoppable force meets an immovable object. Thanks to this, the star core doesn't collapse into a black hole. Sounds wacky. We don't know what dark energy even is, so how can it fill up anything? But luckily, even if scientists can't fully explain dark energy, they still have strong mathematical models to check how it works in our universe. So, they decided to test this theory. Here's where things get even weirder. The new theory says that gravastars might not be simple lone objects. Instead, they could be stacked one inside another. Each one is like a layer with its own dark energy bubble inside, surrounded by a thin skin of matter. The outermost shell would hold a smaller gravastar inside it, and that one could hold an even smaller one, and so on. It's like a series of balloons, one inside the other. The air pressure in each one of them is stable, evenly spread out. Thanks to that, none of them deflate. They coexist without one popping or collapsing the others. In the case of gravastars, the air is dark energy, and the rubber is the shell of matter surrounding it. It sounds crazy, but it actually makes this whole idea more realistic. A single gravastar might have a very thin shell of matter, but the thicker they are, the more likely it is to exist in a stable way. And finally, the coolest part about them is that they could explain one of the biggest mysteries of our world: how universes are born. When a star collapses into a gravastar, the matter could theoretically implode through the center and create a new dimension. This would connect these objects to the Big Bang itself. Some scientists even speculate that dark energy could be the energy exchanged between our universe and a child universe that's created from a gravastar. Of course, these are all just speculations for now. But where are all those gravastars? And how do we test this? Well, physicists aren't sure either. They're more of a what-if thing than an actual object that they discovered. Those two professors just tried to imagine what would happen if gravity and dark energy worked together like this. For now, the LIGO, a big observatory which detects ripples in space-time, hasn't found clear evidence of gravastars. Another problem is that gravastars would only be stable in specific cases. For example, if they spin too fast or their shell will be too thick, they might start to wobble or break apart eventually, though it could actually take billions of years. Plus, even if we don't see them right now, remember that this is exactly what happened to the black holes themselves. When Einstein published his groundbreaking theory of general relativity, another scientist, Carl Schwarzschild, took his equations and found a solution to them. And that's when he realized, if gravity becomes incredibly strong, the light wouldn't be able to escape, and this could create a sort of hole in space. Einstein even thought that this sounds too weird to be true. It took many years for us to confirm black holes' existence, and we finally took a photo of one just a couple of years ago. You might remember that blurry picture that blew up online? It was Sagittarius A star, an incredible supermassive black hole in the center of our galaxy, Milky Way. So that's why scientists approach gravastars so seriously. And since all the math checked out, which means that these objects are actually possible in real life. Now, we just need to see if they're somewhere out there. What's interesting is that they'd probably look like regular black holes. They could emit high-energy radiation as they consume matter. They might even produce something called Hawking radiation, a type of energy that escapes from black holes. In other words, it would be nearly impossible to tell the difference. But gravastars have a small trick up their sleeve. If their shell is transparent to light, they might bend light in a slightly different way than black holes do. So maybe if they check the way light is bent around the mysterious object, they could spot the difference. And even if it turns out that gravastars don't exist in our reality, they're still valuable to science. They still taught us more about gravity, black holes, and the limits of relativity. About a century ago, people envisioned the 21st century as a time filled with quirky inventions. they weren't far off the mark. We're now one step closer to establishing an actual settlement on the moon. Before we can create a new home up, we need to find a way to stay connected, beyond just transportation and shipping. Being able to send a simple text, even something as casual as, "Hey, how are you?" is essential. We can't move to the moon if we're cut off from Earth. Let me spill some tea. A lunar 4G network is currently being developed. The company leading this initiative is none other than Nokia's Bell Labs. The company, bought by the world-famous Finnish company that started out as a paper mill in the 19th century and later ventured into the cell phone industry, creating iconic devices long before Apple launched its first phone. Once the network is completed, it will be loaded onto a lander, deployed, and connected using specialized radio equipment. But don't think this is just a fun experiment. It has significant purposes. The Lunar Outpost rover, one of the vehicles involved in this mission, will thoroughly explore an area known as the Shackleton Connecting Ridge. Another rover, the Micronova, will investigate a lunar crater in search of ice. When they discover ice and capture images, this information will be first transmitted to the lander and then relayed to Earth, an unprecedented achievement in history. Moreover, the importance of a reliable phone connection cannot be overstated. Currently, astronauts communicate via radio. But NASA aims to establish a lunar communication system capable of supporting high-resolution video. Effective communication during space missions is as crucial as food and water, and with this new lunar 4G technology, video calls on the moon could soon become a reality. Plus, thanks to lunar 4G, we'll be able to track how the endangered species sent to the moon are doing. Oh, sorry, I completely forgot to mention something important. As more species edge closer to extinction today, scientists are collecting samples from animals, plants, and other organisms to store in biorepositories around the globe. Unfortunately, the conditions on Earth are far from ideal for these modern-day Noah's Arks. Hence, the decision to build 1 or 2 vaults on the moon makes perfect sense. On the moon, there's a permanently shadowed region at its south pole. It may seem like a fortunate coincidence, but some lunar craters may meet the criterion of temperature, -320 degrees Fahrenheit, which is precisely what we need for long-term self-storage. Initially, the plan was to construct the vault in lava tubes that run beneath the moon's surface, but that would have posed significant risks. This design requires a special solar-powered cooling system, and any accidental loss of power could be catastrophic, resulting in the destruction of all the samples. However, if we built it in a forever frozen shadowed area, the vault wouldn't need any energy or human maintenance. Bingo! It sounds almost too good to be true, and indeed there are several complications. For instance, dust is an omnipresent issue on the moon, infiltrating everything. If the storage requires seals, a dust mitigation system must be developed, which has not yet been created. So for now, it remains a theoretical concept rather than a practical solution.
40, 50 feet, why don't you turn around and let them get a view from there and...
I know you want to learn about real things, not just concepts. Here's something real for you. The moon is full of human waste, carefully packed into bags. According to estimates, there are around 96 of these bags you'd probably prefer to never open. But you never know what exactly is hidden inside. It could be any product of the human body out there. So, if we ever make it to the moon and you accidentally stumble upon a mysterious bag, my advice is to resist the urge to open it. Instead, you can hand it over to scientists. They say they're eager to get their hands on them. Humans are incredible, in a rather unfortunate way. We haven't even established a proper settlement on the moon yet, but there's already around 200 tons of junk scattered about. It piles up there as if it were a teenager's room rather than a celestial body. Alongside those rather unappealing human waste bags, you'll also find cameras, drills, towels, brushes, rakes, a multitude of other technical items, and, surprisingly, a falcon's feather. I'll explain that in a moment. At the end of Apollo 15's final moonwalk, David Scott pulled out a falcon's feather and a hammer to demonstrate Galileo's theory that in the absence of air resistance, different objects fall at the same rate. Amidst all that junk, there's an actual piece of art, so we could say that the moon, if it doesn't have the very first art museum, at least boasts a small exhibition. The crew of Apollo 15 took a 3.5-inch tall aluminum figure to the moon. Created by a Belgian artist, it's called the Fallen Astronaut, and it was laid on its side with a plaque listing the names of astronauts and cosmonauts who contributed to exploration. But the list of odd objects on the moon doesn't end there. If you ever find yourself in need of cash, you can find it on the moon, since a stack of $2 bills was simply forgotten there. Yep, a lot of material has been collected since 1969, when humans first stepped on the moon.
It's one small step for man, one giant leap for mankind.
Our natural satellite was first seen in a telescope in 1609. But what about its true age? To understand that, we need to start with how the moon first formed. Back in the mid-80s, a conference in Hawaii brought together a bunch of scientists to figure out where the moon came from. They came up with a pretty cool idea. The moon probably formed with the stuff that our planet Earth donated. Picture this. A Mars-sized object crashed into the early Earth, flinging molten materials into space, which eventually came together to become the moon we see today. This theory clears up a lot of mysteries. For instance, it used to baffle folks why the moon has such a small iron core. The answer is simple. It formed from Earth's outer layer, which isn't rich in iron. And that pale crust of the moon? It's just minerals that floated to the top when the molten moon cooled down. At first, the moon was super close to Earth, but it's been slowly drifting away at about 2 inches a year, even while you're watching this video. Figuring out when this all went down, though, is a bit tricky. The Apollo astronauts brought back a bunch of moon rocks, which helped scientists estimate their ages. The oldest ones are around 4.35 billion years old, which is about 200 million years after the solar system kicked off. So, here's the thing. There's no exact date for when the moon formed, but there are several interesting theories. One idea is that the age of these rocks could mean the moon is around 4.35 billion years old. But some scientists who look at how planets form think that most of the material in the early solar system came together way before that 200 million year mark. They argue that a big impact that created the moon happening that late seems pretty unlikely, which means the moon could actually be older than 3.5 billion years. Another interesting thought is that the moon might have gone through some serious heating events as it moved away from Earth. This is similar to what happens on Io, one of Jupiter's supervolcanic moons. The gravitational pull from a bigger body can stretch and compress a smaller one, generating heat, like when you squeeze a rubber ball. The rocks on both Io and the moon warm up this way. Rocks have radioactive elements that act like internal clocks, helping scientists figure out their ages. The catch is, if the moon heats up too much, it resets those clocks and only starts keeping time again once it cools down. So those rocks that are about 4.35 billion years old might not actually mark the moon's birthday. They could just indicate a time of tidal heating. This suggests, once again, that the moon had to have formed even earlier than that.
You're standing next to a huge floor-to-ceiling window of the spaceship/wandering city you've been calling your home for a dozen years, along with a few hundred other people. You're watching a fascinating object nearing your spaceship, wondering if it'll bring an end to this journey and your life. It looks like an asteroid, but acts like a comet, moving as if something is pushing it. Can it be the engine created by another space civilization? Are you doomed, or are you about to have contact with a different kind of intelligence? Now, let's leave this post-apocalyptic fantasy and take a closer look at these space invaders called dark comets. The most intriguing question is obviously, what makes them move? Most likely it's some gas or material escaping from the surface of these space objects. Interestingly, until recently, no one has even been sure they existed. The first dark comet was discovered just a few years ago, and since then, researchers have identified 14 of them, including 7 new ones found just recently. The story of dark comets began in 2016, when scientists noticed something strange about an asteroid called 2003 RM. Its orbit wasn't quite what they expected. It had shifted slightly, and no one could explain that shift by typical asteroid behavior, when they received tiny pushes caused by sunlight heating an asteroid unevenly. Instead, the movement suggested that 2003 RM might have been releasing material, something comets often do. But there was a catch. The thing didn't look like a comet. There was no tail, no visible gas cloud. It was just a tiny dot of light, like a regular asteroid. At first, scientists thought 2003 RM was just a one-off mystery. But in 2017, a telescope spotted another strange object, this one from outside our solar system. It was Oumuamua. It too looked like an asteroid, but had a path that changed as if gas were escaping from it. The similarities between Oumuamua and 2003 RM made researchers think there might be more of such odd objects out there. By 2023, 7 more had been discovered in our solar system. These discoveries were enough to give this new type of object the name of dark comets. Now, scientists have enough data to start noticing patterns and learning more about their characteristics. And so, they have identified 2 main groups of dark comets. The first group, called outer dark comets, is larger, with sizes ranging from hundreds of feet to even more. They follow long elliptical orbits, similar to traditional comets that come from regions near Jupiter. The second group, inner dark comets, is smaller, usually tens of feet across. These comets move in almost circular orbits and stay closer to the Sun, near planets like Earth, Venus, and Mars. The main question these days is, where do dark comets come from? Can they be the remnants of larger bodies that broke apart? These space bodies could help us understand the history of the solar system. What if they had delivered the ingredients for life to early Earth? Once we study dark comets better, we might figure out if they contain materials like ice or organic compounds. And indeed, some researchers are sure that dark comets may contain, or once have contained, ice and played a big role in bringing water to Earth. According to a couple of studies, some asteroids in the asteroid belt, a region between Mars and Jupiter filled with rocky debris, might have ice beneath their surfaces. And this ice from the asteroid belt could have traveled into near-Earth space. In other words, it could be a pathway for water to reach our planet. So far, no one is saying that dark comets definitely brought water to Earth, but they might be another mechanism for moving ice from one part of the solar system to another. The study also hints at a connection between dark comets and a group known as Jupiter family comets. These are comets whose orbits are strongly influenced by the gravity of Jupiter, often pulling them inward toward the Sun. This connection makes it even more difficult to understand where dark comets come from and how they behave. Now, let's take a closer look at the differences between asteroids and comets. Traditional asteroids are rocky bodies that orbit relatively close to the Sun, typically within the ice line. This region is so close to the Sun that any ice on an asteroid's surface would turn directly from a solid into a gas, leaving behind only rock. Comets, in turn, are icy bodies that form farther from the Sun. When they approach the inner solar system, their ice starts turning from a solid to a gas tube, creating a visible cloud called a coma or a tail while releasing dust and gas. Dark comets blur these definitions. They appear as rocky asteroid objects without a coma or tail, but they have behavior typical of comets, and that's small non-gravitational accelerations. These accelerations occur when ice turns into gas, giving the object a slight push. After analyzing 7 known dark comets, Astronomers estimated that between 0.5% and 60% of all near-Earth objects might belong to this mysterious category. And since dark comets likely come from the asteroid belt, ice is likely to exist even in the regions of the belt previously thought to be too warm. Now, near-Earth objects like dark comets don't stay in the same orbit forever. The near-Earth environment is unstable, and objects typically remain there for about 10 million years. Since the solar system is over 4.5 billion years old, this means that new near-Earth objects must constantly replace those that are lost. Now, astronomers have used computer models to simulate the movement of objects under the influence of non-gravitational accelerations. They've traced the paths of these objects over a span of 100,000 years and discovered that many ended up in the same regions where we find dark comets today. Now, do you remember that space rock 2003 RM, which was the first to be called a dark comet? Well, it provided a particularly interesting clue. Its elliptical orbit brings it close to Earth, then out near Jupiter, before returning to Earth again. This trajectory matches what scientists would expect from a Jupiter family comet, an object that was likely knocked inward from its original orbit. Most of the other dark comets studied, however, seem to have come from the inner regions of the asteroid belt, closer to Mars. Dark comets are often small and spin rapidly. Astronomers often describe them as dirty ice cubes, all because these objects are a mix of rock and ice, and when they cross the ice line, their ice begins to turn into gas. This process not only causes those small non-gravitational accelerations, but also increases their spin rate. And the faster these objects spin, the easier they can break apart into smaller fragments. The pieces that break off also have ice, and as they spin faster and faster, they break into even smaller pieces. This process continues until you're left with very small, fast-spinning objects. This cycle of fragmentation helps explain why dark comets are often so tiny. But it could also mean there are more of them than we currently know about. The dark comet research provides new insights into the distribution of ice in the solar system and its potential pathways into the near-Earth environment. It also raises intriguing questions. For example, how much ice remains hidden in the asteroid belt? Or could dark comets have played a role in delivering water or organic materials to Earth? One of the most important points is that dark comets may represent a significant part of near-Earth objects. If it turns out to be true, it could mean that our understanding of the population of near-Earth objects and their potential risks for our planet is far from complete. The processes shaping dark comets, from sublimation to fragmentation, could be a major factor in the evolution of icy bodies throughout the solar system. Luckily, these days, scientists have an opportunity to combine advanced modeling with observations, which can eventually shed light on that very elusive class of objects that could have clues to the history of water and life on Earth. So, how do you feel about cooking? Nah, pasta and burgers are overrated. How about something more exotic, or rather, more cosmic? So, the recipe is simple. Take a team of enthusiastic astronomers and add some old images from the James Webb Space Telescope. Stir really well, and you'll get a shocking number of tiny asteroids in the asteroid belt between Mars and Jupiter. Yummy! The highlight of this dish is the direction in which some of the asteroids are moving, because in their way, there's our poor planet. Are we doomed just because you decided to cook? Now, the asteroids I'm talking about are much smaller than the massive space rock that wiped out the dinosaurs, but they can still cause considerable damage. They range in size from as small as a bus to as big as a stadium. But even those small ones pack quite a punch. Let's look at a recent dramatic example. It happened on February 15, 2013. A small asteroid just tens of feet wide exploded in an airburst over Chelyabinsk in Siberia, releasing an insane amount of energy. Many people witnessed and recorded the event, and it gave scientists vital clues. New computer models helped scientists reconstruct the size, speed, and impact of the Chelyabinsk meteor. It was likely an asteroid, about the size of a 5-story building, exploding from 15 to 18 miles above Earth's surface with an enormous, incomparable force. The blast shattered 1 million windows and hurt over 1,000 people. Fortunately, it wasn't powerful enough to cause too much damage. but it gave us an idea about how dangerous an airburst can be. Now, an airburst occurs when an object explodes high in the atmosphere, never striking the ground, but releasing enough energy to devastate the area. But back to the small asteroids. The most dangerous thing about them is that they hit the Earth far more often than the larger ones, about 10,000 times more frequently. To make matters worse, their small size makes them harder to detect in advance, leaving little time for preparation if one is heading towards Earth. Now, let's travel back in time. Uh-oh, dinosaurs, too far back. Ah, there we go. A team of astronomers is working on a special method to find small asteroids in telescope images that were originally taken to study distant stars. Using this method, they've looked through thousands of JWST images of a star system called TRAPPIST-1. It's located 40 light-years away and is one of the most studied systems outside our solar system. Now, while analyzing these images, they discovered 138 new asteroids in the main asteroid belt, plus 8 they already knew about. And guess what? Among the newly found asteroids, 6 seem to have been pushed into paths that could bring them closer to Earth. Who did it? Well, probably nearby planets. Are they holding a grudge against Earth? Interestingly, scientists thought they'd find just a few new asteroids, but the number was much higher than they expected. Yet, it's no wonder. Right now, they're exploring a part of space they didn't know much about before. Now, let's talk about the hero of the day, the James Webb Space Telescope. It's especially good at finding small asteroids because it can detect their heat. These asteroids give off infrared radiation, which is much easier to see than the faint sunlight that reflects off their surfaces. This technology allowed scientists to spot the smallest asteroids ever seen in the main asteroid belt. The asteroids they found are pieces left over from collisions between bigger space rocks. Finding them helps astronomers understand the history of the asteroid belt and improve methods for tracking small asteroids that could threaten Earth. The researchers are planning to use James Webb to observe other star systems for at least 500 hours. They expect this work to uncover thousands more small asteroids in the solar system. Other advanced telescopes, like the Vera C. Rubin Observatory in Chile, will also help. Starting in 2025, this observatory will use the world's largest digital camera to photograph the southern sky every night for at least 10 years. Each image will cover a huge area of the sky, about 40 times the size of the full moon. The observatory might find up to 2.5 million asteroids in just 6 months, almost doubling the number we know about. Recently, NASA has identified 2 small asteroids. They were supposed to pass near Earth on December 16, 2024. Luckily, neither posed any danger to our planet. The first asteroid was 71 feet wide, about the size of a large airplane, and was traveling at 10,800 miles per hour. The second asteroid was slightly smaller, 56 feet wide, but it traveled faster at 14,700 miles per hour. But hey, even though this time the danger is past, who knows what the future will bring? It may sound weird these days, but astronomers didn't really care much about small asteroids for a rather long time. They thought of them as just random space debris that got in the way of observing stars. Some even called them sky parasites. But now, the way we see these little space rocks has completely changed. You see, until recently, we could only spot really big asteroids, those over a mile wide. The smaller ones just blended into the background noise in telescope images. But then, a clever trick appeared where multiple images of the same part of the sky were combined, making those faint small objects finally stand out. The data from certain telescopes, along with the James Webb Space Telescope, helps us improve planetary defense. But there's more to it than just protecting our planet. Studying these small asteroids also teaches us about how the solar system evolved. There are so many of them because they're fragments from collisions between bigger space rocks. One researcher has said this is like looking at old data in a new way. These small asteroids, which people used to think of as space junk, are crucial for understanding our solar system and even preparing for whatever the future holds. Among those hundreds of millions of rocks orbiting the Sun in the asteroid belt between Mars and Jupiter, some are especially worrisome. They come close enough to Earth for it to be quite concerning. NASA classifies asteroids that orbit within 30 million miles of our planet as near-Earth objects, and those could pose a serious threat if they were to collide with our planet. Right now, NASA is closely monitoring an asteroid named Bennu. This is a fairly large space rock, measuring about 1,600 feet across. It could, potentially, crash into Earth in 159 years. First, the astronauts spotted it in 1999. So currently, experts believe that there's a small chance Bennu could drift into Earth's orbit and collide with our planet by September 24, 2182. Would it be bad? Well, to put it in perspective, Bennu is taller than the Empire State Building. If it hit Earth, it would generate 1,200 megatons of energy, an amount so massive that nothing on Earth could generate that. NASA scientists are particularly concerned about a tiny chance that Bennu could pass through a gravitational keyhole during a flyby in the 22nd century. This keyhole is a region in space that could set the asteroid on a path that brings it directly to Earth. Now, Bennu flies by Earth every 6 years and has had 3 close encounters with us in 1999, 2005, and 2011. Right now, scientists estimate that the chance of Bennu hitting Earth by 2182 is about 1 in 2,700, more than 5 times greater than the chance of being struck by lightning. Although the chances of Bennu colliding with Earth are very low right now, this space rock is still classified as a potentially hazardous asteroid because it might come as close as 4.65 million miles to Earth. Now, this asteroid is another space rock that we need to keep an eye on. It's a near-Earth object about 1,100 feet across, and it was discovered in 2004. Initially, it was considered one of the most dangerous asteroids ever detected. Apophis quickly gained attention because experts believed it could pose a serious threat to Earth because of its close approach to our planet in 2029. However, after further study of its orbit, astronomers determined that there was no risk of a collision for at least a century. Well, we can all breathe easier now, can't we?
Jupiter is the largest planet in the solar system. More than 1,300 Earths could fit inside this gas giant. It's also 2.5 times more massive than all the other planets of the solar system combined. But if you think this is mind-boggling, I've got some great news for you. Very recently, a team of astronomers have discovered a much bigger planet with the help of the Subaru telescope and the NASA Hubble Space Telescope. It's a Jupiter-like protoplanet orbiting a very young star, AB Aurigae. The star is probably still forming and is no more than 5 million years old. For comparison, our Sun is 4.6 billion years old. The young star is located at around 531 light-years away from Earth in the constellation of Aurigae. The star is shrouded in a thick, quickly moving layer of gas and dust. This disk feeds the growth of the star. Later, what's left of the disk will come together to form the elements of the planetary system. Planets, dwarf planets, comets, asteroids, you name it. But back to the newly discovered planet. It's a gas giant whose mass equals that of 9 Jupiters. Can you imagine this colossus? It takes the planet, named AB Aurigae b, almost 588 Earth years to complete just one journey around its parent star. Maybe because it's 93.9 AU, astronomical units, away from it. Now, why is the discovery of this planet so amazing? Because according to astronomers, it's been forming in a very bizarre way. Or should I say, is forming, since this gas giant is still in the process. Anyway, the unusual thing is that AB Aurigae b is coming together as a result of a top-down gravitational collapse of giant clouds of gas. But scientists say that a much more common model of planetary formation is when dust and rocks gradually accumulate around some kind of core. This proves the idea that there are numerous ways for planets to form. It can also mean that there probably are very diverse planetary systems in our home Milky Way galaxy. But AB Aurigae b isn't the largest exoplanet ever discovered. In 2005, astronomers spotted a mysterious space body. Later, they called it GQ Lupi b. The thing was orbiting a young star at a distance 2.5 times greater than that between the Sun and Pluto. Scientists came to the conclusion that the object was either a planet or a brown dwarf, which is basically a tiny star. If astronomers decide that GQ Lupi b is a planet, it will be the largest ever found, with a radius that is 3.5 times that of Jupiter. The biggest star we know about is called Uy Scuti. This hypergiant has a radius that is about 1,700 times greater than that of the Sun. If you somehow manage to place Uy Scuti in the center of the solar system, its edges would stretch far beyond Jupiter's orbit. As for the dust and gas streaming from the star, all this would extend beyond the orbit of Pluto. That's 400 times the Sun-Earth distance. A black hole is a spot in space where the pull of gravity is so strong that even light can't escape it. But why is gravity so powerful there? Because matter is squeezed into a teeny tiny space. Supermassive black holes, which can be many millions of times the mass of the Sun, tend to lurk in the centers of galaxies. The most massive black hole astronomers have discovered so far is TUN 618. Its mass is equal to that of 66 billion suns. It was the year 2010. With the help of the Fermi telescope, astronomers spotted something ginormous, something entering the Milky Way. Their discovery looked like massive blobs of matter that could only be observed in particular wavelengths of light. They were also about 25,000 light-years tall. Scientists think that the blobs, called Fermi bubbles, could be produced by our galaxy's central black hole. Space seems to be extremely deserted, but some places are even emptier than the rest, like Supervoid in Eridanus. Astronomers noticed this huge region of empty space in 2004. The area stretches 1.8 billion light-years across. It's mysteriously devoid of gas, dust, stars, and even dark matter. A nebula is a massive cloud of gas and dust floating in space. Some nebulae form when a star is nearing the end of its life and throws out loads of gas and dust. Others appear in regions where new stars are forming. The largest nebula we know about is the Tarantula Nebula. In its longest span, it measures over 1,800 light-years. This nebula, also known as 30 Doradus, is located around 170,000 light-years away from Earth. Unlike its namesake, the tarantula isn't dangerous. Quite the opposite. It's a stellar nursery, which means it's a region where tons of young stars are born. Even cooler, it's the most active star-forming area in our entire galactic neighborhood. In 2021, the biggest ever comet we know about entered our solar system. It was 85 miles across, and its icy nucleus was 50 times greater than the nucleus of the previous record breaker. The intruder's mass was a whopping 100,000 times bigger than that of the average comet. In fact, see 2014 UN 271, Bernardinelli Bernstein, was so large that astronomers first classified it as a minor planet. Is it going to crash into Earth? Nah. It won't get closer than 1 billion miles to our beautiful green planet, and it won't happen until 2031. But could there be comets even bigger than that? Who knows, but the thought is terrifying. There are loads of bizarre things in the universe, and hypothetical nuclear pasta is one of them. If it does exist, nuclear pasta is the strongest material in the entire universe. It forms from the leftovers of extinguished stars when this substance gets squeezed into spaghetti-like tangles of material. It can theoretically break, but only if you apply 10 billion times the pressure needed to shatter steel. Pulsars are spherical space objects the size of a large city, but they pack more mass than the entire Sun. They radiate two narrow beams of light, sending them in opposite directions. The Black Widow pulsar, just like its spider namesake, is munching on its partner. It's a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes its companion star to dwindle. Oumuamua is a dwarf planet orbiting the Kuiper Belt. It's a donut-shaped ring of objects around the Sun that extends just beyond the orbit of Neptune. The mini-planet has a bizarre, elongated shape and 2 moons. The day on this planet lasts just 4 hours, which makes it the fastest spinning large object in the solar system. But the most mysterious thing about Oumuamua is that the planet has a thin, 40-mile-wide ring circling it. What is it? Where did it come from? No one knows. Could be the result of a collision that happened in the distant past. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because it looks like a ring of dust and debris circling it. It makes the star look like a giant eye staring into your soul. The intimidating star is more than twice the mass of the Sun. It's 25 light-years away from Earth, which isn't that far away considering distances in space. Look at this butterfly. Its wingspan is more than 3 light-years, and the structure inside this nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an incredible 450,000 degrees Fahrenheit. It means it was formed from another gargantuan star, more than 5 times the size of the Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass or a butterfly.
TRES-2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its Sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the Sun. The planet is always turned to its star on one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, I'm not going to say that again, is the only exoplanet in the orbit of its star. And at first glance, it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler 70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you asked. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that Thumbworth. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Karat Exo 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core.
In the vast expanse of the universe, there are planets unlike any we've seen before. Planets with a treasure trove of diamonds. What mysteries do these sparkling worlds hold? What do they look like? And most importantly, just how much would it all cost? Let's find out. First of all, let's take a look at diamonds in general. We see them as rare and valuable gems, but did you know that they actually come from something as ordinary as carbon? That's right, this is the same element that's found in your pencil lead or coal. This is also the key ingredient in a diamond. But how does a plain old carbon atom turn into a dazzling diamond? Well, it all starts deep beneath the Earth's surface. At depths of around 100 miles, carbon is exposed to temperatures of over 2,000 degrees Fahrenheit and pressures of over 825 pounds per square inch. That's like putting the weight of 3 elephants on a postage stamp. Under these extreme conditions, the carbon atoms bond together in a unique way. They form the crystal lattice structure that gives diamonds their distinctive shape. This process can take millions or even billions of years as the carbon slowly makes its way closer to the Earth's surface through volcanic activity. And then, finally, the diamond is formed. After that, it may stay hidden in the Earth for thousands of years until it's brought to the surface through volcanic eruptions. From there, the rough diamond is cut and polished into the beautiful gems that we know and love. So, why are diamonds so valuable? Well, it's partly because of their rarity. Only a small fraction of the diamonds that are formed actually make it to the surface. But it's also because of their beauty and durability. Diamonds are the hardest substance known to humans, and they have a unique ability to refract light in a way that makes them sparkle and shine. Diamonds also have a wide range of practical applications. They're used in cutting tools, grinding wheels, and even in the tips of surgical instruments. And thanks to advances in technology, scientists are finding new ways to use diamonds in fields like electronics, energy storage, and medicine. All this goes to show that sometimes the most extraordinary things can come from the most ordinary of elements. Now that we know this, let's get back to our diamond planet. Can planets like this even exist? Actually, yes, they can. In fact, we come across diamonds in space much more often than on Earth. In space, extreme pressure and temperatures are very common. That's why the universe, and even our solar system, is actually incredibly wealthy. Your regular asteroid can cost millions of dollars. Helium, which we can find almost everywhere in space, has a huge energy potential. It's not surprising that humanity has been discussing the possibility of space mining for some time. Now, as I mentioned earlier, diamonds are formed deep within the Earth under conditions of extreme heat and pressure. Scientists believe that a similar process could occur on a planet that's rich in carbon. There are a few possible ways it could happen. For example, when 2 planets or asteroids that contain a lot of carbon collide with each other. The collision would create a shockwave that would push the carbon atoms together so tightly that they would form a diamond. The second way it could happen is if this region of space contains a lot of carbon. If the conditions are right, then the carbon atoms would come together and form a planet-sized diamond. It's like if you have a lot of Lego blocks and you put them together to create a big Lego structure. In other words, if 2 carbon-rich objects collide with each other, the carbon atoms can be squeezed together so tightly that they form a diamond. And now, surprise, surprise, these planets actually do exist. The planet we're talking about is called 55 Cancri e. It's one of the 5 planets in a small system in the constellation of Cancer. Its star is actually so bright that you can see it with the naked eye. It's located 40 light-years away from us, which may be trillions of miles, but on a space scale, it's pretty close. 55 Cancri E was first discovered in 2004. However, we didn't learn until 2012 that it was the first known diamond planet. All thanks to the research of scientists from Yale University. This planet is the Super-Earth. This is a class of planets that are larger than our Earth, but too small to be considered giants. It's about twice as big as our Earth and about 8 times heavier. The planet rotates around its star really fast. It completes a full turn in just 18 hours. This means that 1 year on the planet is less than a day on Earth. It's also tidally locked to the star. In other words, one side of this planet is always turned towards the star and therefore is incredibly hot, while the other is in eternal darkness, just like with our moon. Also, 55 Cancri E is about 25 times closer to its star than Mercury is to our sun. As a result, the temperatures there are just enormous. On the day side, they're just above 4,000 degrees Fahrenheit, and on the night side, which, by the way, is considered the cold one, over 2,500 degrees Fahrenheit. Doesn't really sound like a good place to chill out, does it? Well, it may not be good for us, but for diamonds, it's just perfect. After studying the planet, scientists concluded that it's a rocky world full of carbon. But this carbon isn't contained there in the form of gas. Instead, it's in the form of graphite. Yes, the same one found in your pencils. And, of course, diamonds. According to some estimates, diamonds can make up at least a third of 55 Cancri E. It can cost about $27 non-million. There are 30 zeros in this number. Can you imagine that? But the most interesting question is, what would such a planet look like? First of all, the thermal evolution and tectonic processes there are completely different compared to our Earth. In other words, the planet should be full of strange volcanoes and some bizarre volcanic activity. Weird mountains and stuff like that. In addition, the planet is probably covered with large clouds of dust, and the atmosphere on it is very dense. Oh, and the weather there is definitely crazy. The researchers are planning to learn about the composition of 55 Cancri E's atmosphere in the future, but right now it's already pretty clear that this planet can't be called habitable. Well, finding life there is theoretically possible, but it's very unlikely. Life on a diamond planet could potentially exist deep underground, for example. On Earth, we've already observed bacteria and microbes that can survive under incredibly extreme conditions. These guys are very resilient. They're capable of turning chemicals into energy and surviving, basically anywhere. So, on a diamond planet, life could potentially exist in this form. And who knows, extraterrestrial life may also take forms that are completely unknown to us. Wouldn't it be cool to discover some crystal creatures capable of surviving in the most extreme heat? That would be mind-blowing! And guess what? It's not just 55 Cancri E that's full of diamonds. Other potential diamond hotspots include Pluto's largest moon, Charon, and a Jupiter-style exoplanet rich in carbon found 1,200 light-years from Earth called WASP-12b. Scientists even think that diamonds rain on Saturn and Jupiter regularly. All this was discovered by the researchers from Arizona State University. They claim that diamond planets are not that rare at all. According to a 2020 scientific report, they form around certain types of stars that have high carbon-to-oxygen ratios. They went above and beyond to study these space gems. They subjected carbide silicon to insanely extreme pressures above 50 GPa and temperatures as high as 2,500 degrees Kelvin to see what would happen. And they discovered that under these wild conditions, carbide silicon transforms into diamond and silica. So if you're looking for some diamond bling, you might not have to go too far. You could go intergalactic and explore some of these diamond planets. These exoplanets are unlike anything in our solar system. And who knows what other awesome discoveries are out there waiting for us to find them.
Arr, hold on to your telescope, space rat. Scientists have made an astonishing discovery. They've found the ancient heart of the Milky Way galaxy. But what is this ancient heart? And what does it tell us about the history of our galaxy? Let's find out. Is that it? Yes, and thank you, Captain Jack. My pleasure. What can I say? He's a space pirate. Now, the Milky Way isn't just a candy bar, but a majestic spiral galaxy that's home to billions of stars, planets, and other celestial objects. And it's all spread out over a distance of about 100,000 light-years. The Milky Way has a distinct shape, with a central bulge and spiral arms that extend out from it, kind of like what I look like from the side. The spiral arms are like the suburbs, where the stars are more spread out and the neighborhoods are quieter. They're made up of gas, dust, and stars that all move together in a circular pattern around the center. In between the spiral arms, there are vast regions of empty space, known as interstellar space. Here you can find wispy clouds of gas and dust, as well as some of the most spectacular sights in the galaxy, like massive star-forming regions and colorful nebulas. The Milky Way is also surrounded by a huge halo of dark matter, a mysterious substance that we can't see but can feel its gravitational effects on the galaxy. This halo helps to hold the galaxy together, and it extends out much farther than the visible parts of the Milky Way. And finally, here's the center. Here, the most action happens. In the center of the Milky Way, there's a supermassive black hole, which is about 4 million times more massive than our Sun, Sagittarius A star. This black hole is responsible for some of the most energetic events in the galaxy, like the emission of powerful jets of energy. Remember the famous first photo of a black hole that flew across the internet? It was Sagittarius A star. We managed to capture this black hole because it's the closest one to us. All in all, the center of the Milky Way is full of stars that are tightly packed together, forming a dense cluster. And it was here that astronomers recently made a new epic discovery. The heart of our Milky Way galaxy has been found, and boy oh boy, is it an old-timer. Hey, who are you calling an old-timer? Now, a team of brilliant scientists have found a cluster of 18,000 stars, born right after the Big Bang. Together, they form the ancient nucleus of our Milky Way. These stars date back to a time when our galaxy was just a wee little baby, a mere collection of proto-galaxies, huddling together to form a bigger and better thing. The scientists called it the poor old heart of our Milky Way. Can you believe it? These ancient stars are over 12.5 billion years old. And yeah, maybe they account for a mere 0.2% of our galaxy's total mass. But that doesn't matter. These stars are the building blocks that form the core around which all the other stars and planets took shape. But how exactly did they become this heart of the galaxy? How did they form? And how did we discover all that? To answer these questions, we'll have to plunge into the past, a very, very distant past. Once upon a time, about 14 billion years ago, there was the Big Bang. Our universe was born. At first, it was incredibly hot, but as time passed, things started to cool down and tiny pockets of gas began to clump together due to the force of gravity. These were the first galaxies. The Milky Way is one of these galaxies. It also started as a small clump of gas and dust, but over time, it began to take shape. The very first stars, protostars, began to form within the clouds, and their gravitational pull caused more stuff to come together. This process continued for millions of years until the Milky Way was formed. But to learn the history of our galaxy in more detail, we need to find these protostars, and this is far from an easy task. Researchers have discovered the ancient heart using a neural network to analyze data from the European Space Agency's Gaia mission. The Gaia telescope is a space observatory launched by the European Space Agency in 2013. Its job is to map the position and movement of more than 1 billion stars in the Milky Way galaxy. 1 billion stars! That's like counting every grain of sand on a beach. It's a huge job, but Gaia is up to the task. So, how do they do it? The telescope has 2 cameras that take pictures of the sky at the same time. These cameras are so powerful that they can detect stars that are 1,000,000 times fainter than those visible to the naked eye. Gaia takes many pictures of each star, and this allows us to track their movements with incredible precision. Thanks to the data collected by Gaia, astronomers are learning more about the structure and history of the Milky Way. They've discovered new details about the stars, including their ages, temperatures, and chemical compositions. Gaia is also helping astronomers search for exoplanets, or planets that orbit stars outside of our solar system. So, for this research, astronomers use Gaia and the most accurate 3D map of the Milky Way ever compiled. They had to analyze around 2 million stars to find the primordial group. One way that astronomers can determine the age of stars is by looking at its brightness and temperature. This way, they study a brief phase of stellar evolution known as subgiants. But imagine searching through the huge center of the Milky Way for the tiniest group of stars that are older than 12.5 billion years. This is like searching for a needle in a haystack. Luckily, they had a trump card up their sleeve: metals. You see, in the early universe, the cores of these stars were so hot and dense that they were able to smash atoms together to form heavier elements. These heavier elements are called metals in astronomy, even though they're not really metals like the ones we're used to. The more massive the star, the more metals it can create during its lifetime. When the life of the first stars came to an end, they made a big boom and scattered these metals all around. Metals mixed with other gases and joined the newborn stars, and so on. As time passed and the universe got older, more and more generations of stars formed, each one richer in metals than the last. Can you guess what that means? The older the stars, the less metals they should have. So now it was time for some galactic archaeology. The team taught the AI to find the metal-poorest, most ancient stars, and it succeeded. It found a huge cluster, and all of them were within 30,000 light-years from the center of the Milky Way. Then they separated out the stars that formed the ancient heart from the stars that originated in a dwarf galaxy. And finally, we were left with the original stars around which the Milky Way grew. This discovery is incredible. It reveals the remnants of the Milky Way's earliest history. It turns out that simulations of the Milky Way's formation were spot on. The old stars existed just where they were predicted to be. Just imagine, the stars that remember our universe as a baby are still hanging out in the center of our galaxy. Isn't that mind-boggling? So, why is this such a big deal? Well, by studying these ancient stars, scientists have discovered some incredible things. For example, they've confirmed that the Milky Way's core began its life stationary and only picked up rotational speed as it grew. In other words, the Milky Way formed from the merging of 3 or 4 protogalaxies, and these stars were its initial core. But even after billions of years and multiple mergers, the heart of the Milky Way has remained intact, like a sheltered oasis in the midst of cosmic chaos. All in all, the Milky Way is a vast and complex place, full of mysteries and wonders waiting to be discovered. It's a true marvel of the universe, and we're lucky to call it our home. But the research isn't over yet. Scientists are eager to learn even more about the formation of the Milky Way and hope to study these ancient stars in even greater detail. Who knows what secrets they might uncover? Maybe they'll even discover what types of supernovas exploded to create the elements we see today. So, get ready, Space Rat! The adventure is just beginning! Arr!
Doctor, I can't understand what's going on. I feel dizzy and, how do I say it? I'm tilting. It didn't happen overnight. Like, I didn't wake up and couldn't stand straight. No, one day, I felt that my axis had shifted by 1 inch. Another day, it was 2 inches. And once, you won't believe it, it was 31.5 inches. That's alarming. What if I accidentally turned upside down and all my inhabitants fall off my surface? Ah, dear Earth. We ran some tests and are ready to explain an unfortunate combination of factors that has affected your axis. The last one will perhaps be the most unexpected and upsetting. It all started back in March 2011, when a devastating magnitude 9 earthquake struck off the coast of Japan. It was so powerful that not only did it shift Earth's axis, but it also shortened the length of the day. This earthquake displaced our planet's axis by approximately 6.5 inches and may have moved Japan's main island by about 8 feet. Like other similarly massive earthquakes, it also altered Earth's rotation speed. To make it easier, let's compare it to a spinning ice skater. When a skater pulls their arms close to their body, they spin faster by concentrating their mass near the axis of rotation. Something similar happens during the most powerful earthquakes. They shift Earth's mass closer to its rotational axis, causing it to spin faster and shortening the day length. The calculations showed that the Japanese earthquake sped up Earth's rotation by about 1.8 microseconds, which is about 1.8 millionths of a second. Not a big deal, but at the end of the day, every nanosecond counts. For comparison, the infamous Indonesian earthquake shortened the length of a day by 2.68 microseconds. It struck on December 26, 2004, at 0:58 UTC. The epicenter lay off the western coast of northern Sumatra, Indonesia. This powerful undersea earthquake triggered devastating tsunamis that swept across the Indian Ocean, causing widespread destruction and immense loss of life in countries like Indonesia, Sri Lanka, India, and Thailand. Even coastal areas as far as East Africa had severe damage. The Earth's magnitude, initially recorded at 9.0 on the Richter scale, was later adjusted to between 9.1 and 9.3, making it the most powerful earthquake ever recorded in Asia. The faulting, that's when Earth's crust completely breaks and its parts slide past each other, lasted between 500 and 600 seconds, and it was the longest duration ever observed. The immense force of the quake caused the entire planet to vibrate by at least half an inch and triggered other earthquakes as far away as Alaska. All that immense energy the earthquake released caused subtle but quite measurable changes to Earth. The shift in mass slightly changed the planet's rotation, shortening the day. It also caused a small wobble in Earth's axis from 1 to 2.4 inches toward 145° east longitude. So, when it comes to changes in Earth's rotation speed and axis, it's all about the redistribution of mass. This can happen naturally through disasters, but human activities can also trigger it. Take the Three Gorges Dam, for instance. This massive structure across the Yangtze River in China's Hubei province may seem to be an engineering triumph, but it's pretty ambiguous. Finished in 2012 after nearly 20 years, this massive dam is 7,660 feet long and 607 feet high. And yes, it is so big that it can affect the way our planet spins. Its reservoir is capable of holding 9.5 cubic miles of water, has enough mass to slightly alter the Earth's rotational inertia, slightly slowing the planet's rotation. According to NASA, the Three Gorges Dam reservoir could shift Earth's pole position by almost 1 inch and increase the length of a day by 0.06 microseconds. Dams aren't the only worry. If polar ice melts, water rushes into the oceans, hiking up sea levels, especially near the equator. This mass shift slows Earth's spin way more than dams do. You won't feel it day to day, but it can affect ultra-precise equipment, such as atomic clocks. To fix this, scientists suggested a negative leap second, making a minute 59 seconds, to balance Earth's spin changes. Okay, so you're thinking you've got nothing to do with all those tilts. You don't build dams, right? Bad news. If you take regular showers, you're part of it too. Every time you turn on the tap, you're affecting Earth's tilt just a tiny bit. Thing is, our planet is always shifting and adapting, so even small actions like using water can influence its orientation. Over the past 2 decades, groundwater pumping has caused the Earth's tilt to shift by 31.5 inches. This water redistribution is equal to about 0.24 inches of sea level rise. It turns out that among climate-related causes, groundwater redistribution has the largest impact on the drift of Earth's rotational pull. But what is groundwater? It's the water stored beneath the Earth's surface, filling the spaces in soil, sand, and rock. It comes from rain and other precipitation that seeps into the ground, collecting in underground reservoirs, aquifers. Unlike rivers and lakes, groundwater stays below the surface, acting like a natural water reserve. Thanks to it, we have a steady supply even during dry periods. Many people, especially in rural areas, rely on groundwater as their main source of drinking water. Farmers use it to irrigate crops, while industries depend on it for manufacturing and cooling systems. It sounds pretty harmless, doesn't it? How can something so useful cause our planet to shift? Well, a study covering data from 1993 to 2010 revealed that we've pumped about 2,150 gigatons of groundwater in that time. And this large-scale water removal has shifted the Earth's tilt and rotation. After we use groundwater, much of it eventually flows into the oceans, contributing to rising sea levels. In areas like Western North America and Northwestern India, people use a lot of groundwater, and it may have a connection to these shifts. Yikes, let's face it, all these findings are rather disturbing. But you know, understanding the impact of groundwater use is already a huge step in the right direction. Hey, I'm not done yet. This tilting issue isn't just about stuff happening on Earth. We also need to look at space. We've talked a lot about water, right? Well, you know that the moon has a big role in that. Its gravity is super important for forming tides and all that. So one more thing that affects our planet a lot is the gradual movement of the moon away from Earth. These two bodies interact gravitationally, which makes Earth's rotation slow over time, even though significant events like earthquakes occasionally speed it up temporarily. How did we figure it out? Glad you asked. Once, someone paid attention to ancient corals. After analyzing them, scientists realized that Earth had once rotated much faster. The thing is, corals grow by laying down thin layers of calcium carbonate. They do it daily, and variations reflect seasonal changes. By counting these layers, scientists have calculated the number of days in a year millions of years ago. They found that Earth had about 420 days per year 444 to 419 million years ago. But over time, the moon's influence had caused Earth's rotation to slow. And now we only have 365 days in a year. I feel robbed, you know? At the moment, the moon is moving 1.5 inches away from Earth each year. That's about the same speed at which your fingernails grow. Astronomers have figured it out with the help of special mirrors placed on the moon during the Apollo missions. For over 50 years, researchers have been sending laser beams to these mirrors and measuring the time it took for the light to bounce back. In any case, dear Earth, at the moment, your condition isn't critical. As for your inhabitants, they won't fall off your surface. All thanks to your gravity, pulling them toward your center. Just don't switch it off, and everything's gonna be fine.
Now see here, astronomers have recently discovered a neutron star, also known as a dead star, spinning at an extraordinary speed of 716 times per second. It makes it one of the fastest spinning stars we've ever found in the universe. And it's not just about its speed. The surface of this neutron star is erupting with super powerful explosions almost non-stop. But before we dig deeper into the mystery of this neutron star, let's figure out what these stars really are. They form from the remnants of massive stars that are at least 8 times the mass of the Sun. When such stars exhaust their nuclear fuel, they can no longer counteract the force of gravity pulling their matter inward. This leads to the collapse of their cores, triggering a massive supernova explosion that blows away the outer layers of the star. What's left behind is an ultra-dense core. That's a neutron star. These stellar remnants are incredibly small, typically just 12 miles wide. At the same time, they pack in more mass than the Sun. The density of neutron stars is also overwhelming. Imagine taking the mass of two suns and squeezing it into a sphere about the size of a city. A single teaspoon of neutron star material would weigh around 10 million tons. That's the same as the combined weight of 85,000 blue whales. Such an extraordinary density is what gives neutron stars their immensely powerful gravitational fields. When matter falls onto a neutron star, it accelerates to speeds of millions of miles per hour before slamming into the surface. The energy release from such impacts is truly astonishing. Now, despite its name, inside a neutron star, there are not only neutrons. A few protons survive down there too. Now, normally, protons repel each other since they have the same positive charge. But in a neutron star, that crushing gravity forces them so close together that the strong nuclear force takes over. It pulls them toward the neutrons like they're all part of the same team. Inside the star, things get stranger the deeper you go. Near the surface, neutrons clump into blobs, kind of like a neutron gnagi. A bit further down, these blobs link together into long chains, forming what scientists call the spaghetti layer. I'm getting hungry. At even greater pressures, the spaghetti chains fuse side by side, creating flat sheets. Think neutron lasagna. Keep going any deeper, and the lasagna eventually breaks down into a uniform mass. But even then, the structure isn't smooth. There are gaps, long tube-shaped voids that look a lot like penny pasta. So inside a neutron star, you've got layers of gnocchi, spaghetti, lasagna, and penny pasta. And each of them represents the mind-bending results of physics under insane pressure. Okay, I'm definitely having Italian for lunch today. Now, the recently discovered neutron star is part of a binary system located in a dense star cluster. This cluster is situated near the center of the Milky Way galaxy, approximately 26,000 light-years from Earth, in the direction of the Sagittarius constellation. The record-breaking spin of the star is extraordinary. If we take a period of not a second, but a minute, it'll be over 42,000 revolutions per minute. At the same time, the newbie ties with another neutron star, which spins at the exact same speed. Such extreme rotation rates are rare and make these stars cosmic outliers in terms of behavior and properties. Oh wait, we can't but mention our neutron star's binary partner. It's a white dwarf, a dense remnant of a star similar in size to our Sun. This white dwarf is pretty fast too. It orbits the neutron star once every 11 minutes. This makes the couple a binary system, with the shortest orbital period ever observed. Imagine a stellar object zipping around its partner faster than the time it takes to prepare a cup of coffee. Yep, that's the kind of speed we're talking about here. This tight, rapid orbit shows how powerful gravitational forces are inside the system. So, you might be wondering what makes neutron stars spin so rapidly. It's something called the conservation of angular momentum. Let me explain. When a massive star collapses into a neutron star, it shrinks dramatically. Such a rapid compression gives an instant boost to its spin. It's like an ice skater spinning faster when they pull their arms inward. And the smaller the star gets, the faster it spins, which results in extreme rotation rates. In binary systems like this one, neutron stars can achieve even faster spin rates. Their trick is to steal matter from their companion stars. This process is called theft. No, accretion. The stolen matter carries that very angular momentum, which adds to the neutron star's rotation speed. The accreted material can also build up on the neutron star's surface eventually. It triggers powerful thermonuclear explosions. They release immense amounts of energy, temporarily making the neutron star shine up to 100,000 times brighter than our Sun. It allows astronomers to study the intricate details of these extreme environments. NASA's X-ray instrument on board the International Space Station, officially called the Neutron Star Interior Composition Explorer and thankfully nicknamed NICER, observed 15 thermonuclear explosions on the surface of our neutron star between 2017 and 2021. One of those bursts displayed a unique pattern called thermonuclear burst oscillations. Those are highly asymmetric patches of brightness on the burning surface layers of accreting neutron stars. This pattern matched the spin rate of the neutron star and thus confirmed its extreme rotational speed. But wait, the best part is coming. While neutron stars are already extreme, there's another class of them that takes things to a whole new level – magnetars. Now, magnetars are neutron stars with unimaginably strong magnetic fields, up to 1,000 trillion times stronger than Earth's magnetic field. These fields set them apart from other neutron stars. They can distort atoms in nearby objects, making life impossible anywhere near them. As for the energy density of a magnetar's magnetic field, it's so high that it's 10,000 times greater than the mass density of lead. Magnetars also produce bursts of X-rays and gamma rays that are so powerful they can temporarily outshine entire galaxies. These bursts are often triggered by star quakes, violent shifts in the magnetar's crust caused by their own magnetic fields. For example, a gamma-ray burst from a magnetar in 2004 was so strong that it disrupted Earth's ionosphere. It hit Earth, and it was so intense that several satellites picked it up. The SWIFT satellite, built specifically to detect gamma-ray bursts from across the universe, didn't just detect the blast, it got hit with so much energy that its sensors got completely overloaded. And SWIFT wasn't even facing the burst. The energy was so strong it passed through the spacecraft and still overwhelmed its cameras. If a magnetar was located as close to Earth as the Moon, its magnetic field would erase all credit card data on the planet by wiping the magnetic stripes clean. Whoa, that's the level of power we're dealing with here. Magnetars are extremely active, but for a relatively short time. Their intense magnetic fields decay after about 10,000 years. After that, they stop emitting strong X-rays and gamma rays. Astronomers think that there are at least 30 million inactive magnetars in the Milky Way galaxy alone. These silent cosmic relics are scattered all over the galaxy. Neutron stars and magnetars serve as laboratories for extreme physics. They allow astronomers to have insights into the behavior of certain matter under conditions you can never replicate on Earth. The incredible density of these objects helps scientists figure out what happens when protons and electrons get compressed together to form neutrons. This creates states of matter that don't exist anywhere else in the universe. These violent explosions on neutron stars and magnetars also play a critical role in the formation of heavy elements like gold and platinum. These elements get scattered all over the universe during these energetic events, eventually becoming parts of planets and stars and you and me. Oh, by the way, NASA's NICER instrument has played the key role in uncovering the mysteries of neutron stars. Its ability to detect X-rays with high precision allowed astronomers to study the rapid spin of the neutron star we've been talking about and the thermonuclear bursts that occur on its surface. So, what could be nicer than that?
Imagine an asteroid so full of valuable metals that it could make every person on Earth a billionaire. Well, that's not science fiction. It's 16 Psyche, a massive metallic space rock orbiting the Sun between Mars and Jupiter. It isn't just extraordinary because of its value, estimated at $10 quintillion. That's a figure that dwarfs the global economy many times over. It also has clues about the formation of planets, especially the rocky worlds like Earth. In October 2023, NASA launched the Psyche spacecraft. This mission is to explore the cosmic treasure trove. It's supposed to arrive at the asteroid in August 2029, and astronomers hope that it will give us some insights, not just about the asteroid's glittering wealth, but also about how planets form and evolve in our solar system. But what exactly makes Psyche unique? First discovered in 1852 by an Italian astronomer, it was the 16th asteroid people identified, hence its name. It stands out among the millions of space rocks in the asteroid belt for one main reason: its metallic composition. While most asteroids are rocky or icy, Psyche seems to be made primarily of iron, nickel, and possibly even gold and other rare metals. At about 173 miles wide, it isn't the largest asteroid. It's easily dwarfed by others like Ceres. But its size is still impressive. After all, its surface area is 64,000 square miles, like that of the state of Florida. Astronomers think that between 30 and 60% of the asteroid's surface might consist of precious metals. They also think that this space rock might be the exposed core of a planetesimal. A planetesimal is basically a protoplanet, a large space body in orbit around a star, developing into a planet. And this planetesimal could have grown into a full-fledged planet if it hadn't been destroyed in some catastrophic collision billions of years ago. If this theory is correct, Psyche can give us a unique glimpse into what lies deep within terrestrial planets like Earth, where planetary cores are hidden thousands of miles beneath thick crusts and mantles. Now, remember that spacecraft that went to explore the asteroid? After embarking on its ambitious mission, the Psyche probe will travel a mind-boggling 2.2 billion miles to reach its goal. This journey will take nearly 6 years. On its way to the asteroid, the spacecraft will pass by Mars in May 2026 and use the red planet's gravity to slingshot itself deeper into space. This maneuver is called a gravity assist, and it will boost the velocity of the probe and refine its trajectory toward the asteroid. By the time it reaches its goal in August 2029, the spacecraft will be set to orbit the asteroid for at least 26 months. During this time, it will analyze its surface, figure out its composition, and attempt to unravel its history. The probe is equipped with some pretty cool tools. One of them is called a multispectral imager. This instrument will snap high-resolution images of the asteroid surface. It's supposed to help astronomers to study its texture and composition. Then, the probe has a gamma-ray and neutron spectrometer. This instrument will measure the asteroid's chemical elements, including its metal content. A magnetometer will detect a magnetic field, if any, which could confirm Psyche's origin as a planetary core. And finally, an X-band radio system will help determine the asteroid's gravity field, which can offer insights into the asteroid's internal structure. NASA isn't sending the spacecraft to assess the value of the space rock as a mining target. Well, at least not yet. The main goal of the mission is science. Researchers hope to answer fundamental questions about how planets form and evolve. And this asteroid could help us understand what happens when molten material solidifies into a core. Another question we need to answer to is, why did it fail to become a planet? And understanding the history of the asteroid might shed light on why some celestial bodies grow into planets while others don't. While NASA's mission is purely exploratory, it has also sparked interest from the point of view of asteroid mining. With its estimated worth of $10 quintillion, Psyche could theoretically supply enough raw materials to revolutionize industries on Earth. Mining it is likely to be decades away, if it ever happens altogether, but the idea still sounds amazing. At the same time, if the asteroid's metals were somehow brought to Earth, their abundance could cause the value of precious metals like gold to plummet, and it would wreak havoc on global markets. Speaking of valuable resources, let's find out how Earth got its own gold, platinum, and other rare metals. These elements, aka highly siderophile elements, have a cosmic origin story, and it's every bit as dramatic as Psyche's. These precious metals were born in violent cosmic events billions of years ago. Many appeared in kilonovae, explosive collisions between neutron stars. These metals were then scattered across space and eventually became part of the gas and dust cloud that formed our solar system. When Earth formed, those metals sank towards its iron-rich core, but not all of them ended up deep inside the planet. Destructive collisions with rogue protoplanets like the Mars-sized Theia, which most likely helped to form the Moon, trapped some elements in Earth's mantle. Recent computer models have explained how this happened. After each major collision, Earth's surface temporarily became a magma ocean, a molten layer of rock. As metals sank through the magma, they reached a partially solid layer that slowed their descent, keeping them in the mantle instead of the core. These metals then moved closer to the surface under the influence of thermal convection. That's what made them accessible for mining billions of years later. While Psyche's metals are all over the news, space has more to offer than just gold and iron. Scientists have discovered, or rather theorized, the existence of different gemstones scattered across the cosmos, like diamonds. The thing is, diamonds are made of pure carbon, and this element is abundant in the universe. On Earth, diamonds form deep in the mantle under high pressure and temperature. In space, conditions for diamond formation can occur in surprising places. For example, nanodiamonds, which are really tiny diamonds, have been found in meteorites. Sometimes they contain gases that give us clues about the early solar system. Scientists believe that it might rain diamonds on our ice giants, Neptune and Uranus. There, high pressures compress carbon into crystalline form. Researchers have also predicted that exoplanets in other solar systems could have gemstones like rubies and sapphires, depending on their size and proximity to their stars. Even Earth's moon had its own share of cosmic minerals. Scientists have found some traces of cubic zirconia in lunar rocks. So space might hold even more treasures than we've imagined. But let's get back to the Psyche mission. It might not only reveal the whole potential of space resources, but also underline the issues we could face while dealing with them. For example, mining an asteroid would require the usage of autonomous robots, machines capable of operating in harsh space environments. Plus, we would need efficient transport systems to bring materials back to Earth or process them in orbit. We would need to make sure that mining activities wouldn't damage ecosystems or space environments. There are also legal and ethical issues, like the Outer Space Treaty of 1967. It prohibits any nation from claiming sovereignty over celestial bodies. But with private companies entering the space race, debates over ownership and resource sharing are heating up. And finally, bringing such amounts of metals to Earth could destabilize global markets. So, experts suggest that space resources might be better used in space, for building habitats, satellites, and spacecraft. But no matter whether we ever mine 16 Psyche or not, its exploration will teach us more about the early solar system and the processes that shaped our planet. As of December 1st, 2024, the probe is heading for the asteroid, following the orbit around the Sun. Its journey promises not only to deepen our knowledge of the universe, but also to redefine what's possible for humanity as we reach for the stars.
There's a strange noise coming through the speaker.
2 astronauts are stuck in space right now. It all started when they heard this creepy, pulsing sound coming from inside their spacecraft. A noise that shouldn't even be possible in the vacuum of space. The situation got so strange that their return trip from the International Space Station was cancelled. What was supposed to be just a few days in space has turned into 9 months of a real nightmare. This situation is happening to NASA astronauts Butch Wilmore and his colleague Sunita Williams. On June 5, 2024, they left Earth with one mission: to spend about 24 hours traveling aboard the Boeing Starliner spacecraft until they reached the space station. They were supposed to stay there for only 8 days, working alongside the 7 astronauts and cosmonauts already aboard. After that, they'd head back to Earth on the Starliner. Simple as that. However, just as they were getting ready to return to Earth, something strange happened. Wilmore started hearing this bizarre noise inside the Starliner capsule. It sounded like a heartbeat, with steady intervals. The creepiest part is that space is supposed to be totally silent, since there's no medium for sound to travel through. There are no atoms or molecules to carry a sound wave, so there's no sound or echo. And no one can hear you scream. It is just total silence. So there's no way those weird sounds could be coming from outside the spaceship. The situation got pretty concerning, as the noise just wouldn't stop. On top of that, the astronauts couldn't figure out where it was coming from. I mean, they knew it was coming from a speaker inside the capsule, but they had no clue what was causing it. So, they decided to ask the experts at the Johnson Space Center in Houston for help. Before we continue, it's important to know that odd sounds in spaceships aren't uncommon. Back in 1969, when the Apollo Mission 10 entered lunar orbit, astronauts said they heard a mysterious music coming from the far side of the moon. It was like a whistling sound that lasted almost an hour. It was so bizarre that they thought no one would believe them. Specialists think the sound was caused by radio interference, maybe from a magnetic field or atmosphere. But here's the thing. The moon has no magnetic field and not enough atmosphere to cause these sounds. So, the mystery still stands. Something similar happened back in 2003. Chinese astronaut Yang Liwei was on his first trip to space, alone, aboard a tiny spacecraft, when he started hearing something weird. It sounded like someone knocking on the spaceship's body, almost like knocking on an iron bucket with a wooden hammer. But what was even stranger was that the sound didn't seem to come from either outside or inside the spacecraft. Li Wei never figured out what it was, not even after returning to Earth. The situation was eerie enough to freak him out, probably just like what happened to Wilmore and Williams. But in the case of the NASA astronauts, it looks like they found an answer to the creepy sound. According to the team at Mission Control, the sound was probably just a technical issue. They think it's a speaker feedback loop between the space station and the Starliner. So, that sounds like great news, right? Well, not exactly. Their problems were far from over. The audio issue was definitely a concern for the team at the Johnson Space Center, but honestly, there were a lot of other technical issues going on with their spaceship. Even before the launch, experts noticed a small but persistent helium leak. This could be a big problem because this gas powers the thrusters, which control the spacecraft's orientation, speed, and trajectory. But in this case, the specialists thought, nah, it'll be fine. The leak was at an acceptable level and posed little risk to the mission's success, so they decided to go ahead with the launch. But then, things got worse. Once the astronauts were in space, specialists noticed another helium leak, then another, and another. In the end, they found 5 leaks, which had the mission managers pretty worried. So they urgently contacted Wilmore and Williams. The astronauts were about to go to sleep when they got the order to shut down 2 valves on the spacecraft. That way, it would be safe again and still have plenty of helium left to get them home. And when they thought it was all over, turns out it wasn't. The Starliner also had issues with the thruster control system. The capsule had 28 small thrusters, and 5 of them had technical problems at some point during their trip. 4 of the thrusters were fixed pretty quickly, but 1 of them never worked again. So first, there were the helium leaks. Then the thrusters weren't working properly. And now, there's this weird pulsing sound coming from inside the spacecraft. It seems like the problems with the Starliner just kept piling up. Suddenly, it became way too risky to bring the astronauts home. That's why NASA decided to cancel their return trip. Actually, they delayed it, extending their 8-day stay on the space station to 9 months. So far, they're expected to come back to Earth in March 2025. But it's hard to say for sure, since this date has already been pushed back before. What we know for sure is that both astronauts are stuck in space right now, waiting for the NASA SpaceX Dragon spacecraft to bring them back to Earth. Until then, they're sharing their floating home, which is about the size of a 6-bedroom house with 7 other people. Being stuck in an orbiting laboratory and unable to get home is definitely a desperate and suffocating situation for most of us. But it looks like they're handling it pretty well. Both of them had already done 2 long-duration stays in orbit before, so despite their families, both astronauts are used to it. And they said they're grateful for the extra time in space. Before the mission began, NASA also made sure they understood all the risks of the flight, including the chance they might have to stay at the station longer than planned. That's why both Wilmore and Williams fully supported the new date for their return to Earth. And they've been keeping their minds pretty busy up there, doing a lot of scientific work. One thing they're really focused on is looking after the plant facility at the space station. Their team is testing different techniques to see how they could help crops grow outside Earth. Figuring out how plants grow in space and making sure they get the right amount of water and nutrients is really important, especially as space travels keep going farther and farther beyond the moon. A lot of people are concerned about their safety and health, but there's no need to worry. They're completely fine. Stays on the space station usually last about 6 months or more. Also, the place is well stocked with everything the crew needs, including food, water, clothes, and oxygen. NASA and its partners often send missions with extra supplies to make sure everyone feels safe and taken care of. If Wilmore and Williams feel homesick and have some free time, they can always email, call, or video chat with their family and friends. The Boeing Starliner spacecraft returned to Earth on September 2024, but it came back empty, without Wilmore and Williams on board. It traveled in autonomous mode after undocking from the space station. The Starliner re-entered Earth's atmosphere after 6 hours of travel, using parachutes to slow its descent before landing at the White Sands Space Harbor in New Mexico. The landing was a success, but NASA specialists wish it could have gone as originally planned. I mean, with Williams and Wilmore on board. Now, all we can do is hope they have a safe trip home.
Asteroids are a serious, very real danger. Some of them are big enough to cause a lot of trouble if they collide with Earth. One asteroid in particular is making headlines these days. A new study has revealed there's a small chance it could hit our planet during its close flyby in 2029. But the question is unusual. Will the asteroid survive this encounter? Apophis, which got its name from Apep, the Egyptian deity of chaos and disorder, has become one of the most infamous asteroids. Discovered in 2004, this space object is about 1,100 feet wide. It's about the height of the Eiffel Tower in Paris. Because of its size and the close flyby predicted for 2029, astronomers classify Apophis as a potentially hazardous object. Those are asteroids and other space objects that pass close to Earth and are big enough that we really need to pay attention to them. Right now, scientists say the chances of a collision are slim, less than 1 in a billion. So, at the moment, we can probably claim that Earth is out of danger. But the same can't be said about the asteroid itself. When Apophis passes close to Earth in 2029, our planet's gravity is likely to shake it so violently that it may experience something like an earthquake, a cosmic asteroid quake, if you will. The stress from this gravitational force will probably cause parts of the asteroid's surface to crack off and fly into space. And even though this might not be a full-blown disaster, and the asteroid won't fall apart completely, it's very likely to lose some material during the flyby. Some of this debris might just stick around in orbit, while other bits could fly off into deep space. Over time, this catastrophe could affect Apophis's rotation, causing it to spin differently or tilt in a way it hasn't before. And this is a phenomenon scientists are really interested in, because it could teach us a lot about how asteroids react when powerful gravity is pulling on them. Now, let's get back to Earth. Well, we haven't left. Anyway, even though the asteroid isn't big enough to wipe out the planet like the asteroid that destroyed the dinosaurs, it's large enough to cause serious damage to a large city if it ever collided with Earth. It could mess with the climate all over the planet, too. At the moment, it looks like the space rock will sail past Earth at a distance of around 20,000 miles. It's still worryingly close, but far enough to avoid a collision. To put it in perspective, that's less than a tenth of the distance between Earth and the Moon. So while Apophis likely won't hit us, this flyby could still cause problems for some of the satellites orbiting Earth. They will be much closer to Apophis than we are. The key point is that we can't rule out a risk of a collision in a few more years. As Apophis gets closer, astronomers will keep a very close eye on its trajectory to make sure it doesn't veer off course due to the influence of Earth's gravity. In fact, this gravitational pull could actually cause some serious changes to the asteroid itself. Now, even though Apophis is not likely to cause a global disaster if it were to hit Earth, the consequences would still be pretty severe. The impact could destroy an entire city, and the resulting climate changes could mess with food production for years. It wouldn't be an extinction-level event, but it would still be a huge deal. Now, Apophis is not the only asteroid we need to worry about. Scientists are constantly on the lookout for other asteroids that could potentially cause harm to our planet. Thanks to new technology, astronomers can now track dangerous space rocks from way farther out in space. One cool new method they're using involves studying meteor showers. These showers are actually caused by long-period comets that have been orbiting the Sun for hundreds or even thousands of years. As these comets pass by, they leave a trail of dust and debris, which can end up creating meteor showers when Earth passes through them. Scientists analyze the properties of meteor showers, like their speed, direction, and where they come from. This can help them trace the particles back to their parent comet or asteroid. It's actually a big deal, because it means we might be able to spot potentially hazardous asteroids long before they get close to Earth. The upcoming Legacy Survey of Space and Time project, which is being run out of the Vera Rubin Observatory in Chile, is going to help astronomers track these space rocks from even farther away. Astronomers are going to create a detailed map of the sky and the regions where meteor showers are most likely to occur. It'll help them predict which asteroids might become a problem for Earth in the future, giving us plenty of time to prepare or come up with a plan. But even now, there are many space rocks that can potentially cause a lot of trouble to our planet. Let's look at some of them. Here's the asteroid Bennu. Astronomers discovered it in 1999. This carbon-rich rock is about 1,600 feet across. It's the height of the Shanghai World Financial Center. Didn't you know that? At the moment, this asteroid is the greatest threat to Earth that we're aware of. But don't panic yet. The collision won't happen for a long time. In fact, scientists calculate a 0.037% chance, which is about 1 in 2,700, of Bennu striking Earth on September 24, 2182. I won't be around then. If Bennu does hit our planet, the impact would release so much energy that it would be enough to cause massive destruction in a large region. But luckily, it wouldn't wipe out the entire planet. Still, if Bennu hit a city, the consequences could be catastrophic. NASA's OSIRIS-REx spacecraft has recently visited Bennu and returned with samples, so scientists are learning more about this asteroid all the time. The next asteroid is another one to keep an eye on. It was first discovered in 1950, but wasn't seen again until 2000. Right now, scientists say there's a very slim chance, 1 in 34,500, that it could hit Earth on March 16, 2880, 800 years into the future. So, am I worried? Nah. If it did strike, it would release so much energy it could lead to a global catastrophe, potentially wiping out humanity. Or not. Our next asteroid has been discovered only recently. It was spotted in October 2023. It has a very low chance of striking Earth on October 10, 2119. Man, they got it down to the day? Now, if it were to collide with our planet, the impact would release a lot of energy, which would have a devastating effect for large areas. So, while the arrival of this asteroid is a long shot, this asteroid is still worth keeping an eye on. Now, this asteroid is known as a lost asteroid because it hasn't been seen since 2007. No wonder, it has a very uncertain orbit, and we can't predict its movements. NASA says there's a tiny chance, about 1 in 10 million, that it could strike Earth on March 3, 2030. If it did, the energy released would be able to cause huge regional damage. Finally, we've got this space wanderer. On the one hand, it hasn't been seen since 1979. On the other, scientists believe that there's a very low chance that it could hit Earth on December 14, 2113. Mark your calendars. If it did, the impact would cause a lot of damage and devastation, but it would not lead to the end of humanity. Now, in any case, even though the chances of an asteroid hitting Earth are low, the consequences of such an event could be huge. That's why scientists are so focused on studying these space rocks and tracking their movements. Thanks to new technologies, we can track dangerous objects from farther away and catch them earlier. It can give us more time to react and come up with some effective solutions. So, dark matter is a mysterious substance that makes up about 85% of the total matter in the universe, yet we can't see it or touch it. The regular matter that we're used to forms stars, planets, and everything around us. But dark matter doesn't emit, absorb, or reflect light, which is why we can't even see it. We don't even know if it actually exists. The reason why we believe in dark matter is because it leaves gravitational effects on galaxies and other cosmic objects. For example, spiral galaxies spin in a way that doesn't match the law of physics we know. According to our current knowledge, the outer edges of these galaxies should slow down, but they don't. They either keep the same speed or even speed up. It also seems to be acting like an invisible glue that holds galaxies together. If dark matter didn't add some invisible gravitational mass, the galaxies would literally break apart, not being able to hold stars together. But even though it's fundamentally important for our world, we still don't know exactly what dark matter is made of. This has been going on for years. Some experiments saw hints of it, but no one's been able to prove it beyond a doubt. Maybe the future circular collider will be able to find it. There's a mysterious force in space that seems to be pulling our entire galaxy, along with many others, toward it. This force is known as the Great Attractor. Wink, wink. It's a crazy massive region in space, about 10 million billion times the mass of our Sun, with a super powerful gravitational pull. Scientists think it might be a super cluster of galaxies, but they're not sure. The problem is, we can't see it directly because it's hidden behind the Milky Way, while the Milky Way itself, horrifyingly, is moving toward it at a speed of about 370 miles per hour. Now, just like with dark matter, we only know it's there because of how it affects the movement of galaxies around it. These galaxies are being pulled toward this region, even though, since the universe is expanding, they should be moving away from each other. What's even weirder is that this Great Attractor might itself be moving toward something even bigger, the Shapley supercluster. It's the largest concentration of galaxies in our nearby universe. In 2017, astronomers discovered a strange object called Oumuamua. This was the first known visitor from another star system. The thing was quite small, from about 330 feet to about 0.6 miles long. It was also long and thin, had a reddish color, and moved in a very unusual way. As it passed by the Sun, it unexpectedly sped up and then left our solar system just like that. Tons of theories started sparking up. It was too weird looking for an asteroid. Scientists thought it might be a comet, but it didn't have the usual traits of one, like a tail of gas and dust. Eventually, some scientists even started to suggest the wildest theories, like it might be an extraterrestrial probe. People have been making a huge fuss about Oumuamua ever since. But after a while, it turned out it was just a natural object with unique properties. It was probably a fragment from a distant star system, like a piece of a disintegrated comet or even a chunk of a planet. But Oumuamua caught everyone's attention so much that in 2022, astronomers even proposed to send a spacecraft to catch up with it. This mission could take about 26 years. Hey, stay tuned. Now, as for extraterrestrial creatures, where is everyone? There's this thing called the rare Earth hypothesis that suggests that life as we know it is actually super rare in space. In the 70s and 80s, scientists argued that Earth is just an ordinary planet in an ordinary solar system. If we look at it this way, life should be widespread across the universe. It seems unreasonable to think that with trillions of planets out there, there will be no planet like ours anywhere. But then, a geologist, Peter Ward, argued that the development of complex life like ours depends on a very rare combination of things. The history of the planet, with all of its astrophysical and geological conditions, should line up perfectly for complex life to develop. So just think about it. Being in the right zone of the galaxy, on a good distance around a stable star, a rocky planet with water and the right temperature, emergence of molecules, monkeys deciding to walk, and so on. This would explain the Fermi paradox, which asks, if extraterrestrial life is common, why haven't we seen any signs of it? Well, the rare Earth hypothesis explains it. The universe might be full of plants, extraterrestrial critters, and fun animals. But would there be an intelligent species like humans? That's another story. As for humans being intelligent, that's another matter. Dark matter? And even if they do exist, we could be incredibly far away from each other. That would make communication or contact with other intelligent species very unlikely. Now, there's another similar theory called the Great Filter. This idea says that there might be a big obstacle somewhere along the path from microbes to advanced civilizations. It was the idea of the economist Robin Hanson. He also believed that maybe intelligent life, as we know it, isn't that common in the universe, although he assumed it's not because our planet was the result of tons of unique conditions, but because there must be some sort of filter that reduces the chance of life progressing to our point. Who knows where this filter is? It might be in the stage of early microbes, which means that we managed to get through it or somehow ahead in the future, which means we might go extinct like many other species before us. Well, maybe in the next stages, such as colonizing other planets and the galaxy, are much harder, if not impossible. Something unexpected might come up, potential catastrophes, resource exhaustion, or other challenges. Now, there's this thing called a pulsar. It's a weird type of star that sends out regular bursts of radio waves, like a flickering space lighthouse. You see, in space you often find a pulsar and a smaller companion star that rotates around it. But one day, scientists discovered this system, which was also surrounded by tons of some energetic material. They suddenly realized that these are probably the remains of another companion star, which was very big in size. But the pulsar was blasting out powerful radiation and particles, slowly consuming its companion. This is kind of like how a black widow spider eats its mate, hence the name. Since then, they've found other similar systems. They've grouped them all into one spider family. There are also redback pulsars, which destroy slightly larger companions, and huntsman pulsars, which have companions that are massive enough to resist being completely destroyed. Even though so many safety measures are taken, space is still an unpredictable place where we don't have as much power as we'd like to. Back in 1973, during a spacewalk on the Skylab space station, 2 astronauts were in a very risky situation. They were out in space fixing things, but they didn't have the same handy jetpacks like astronauts do today. They could only rely on safety tethers. Suddenly, the solar arrays they were working on moved unexpectedly and pushed them out of their position, almost sending them drifting off into space. Thankfully, the safety ropes did their job. Strong, resistant to heat, and attached to astronauts' waists, these tethers can hold a weight of about 881 pounds. This accident happened before SAFER came into use. It's easy to understand why accidents at work are way scarier up there than some regular 9-to-5 job on Earth. But that's why you have more training and special equipment to keep you safe. First, astronauts are always attached to the spacecraft with tethers, so they don't float away like a helium balloon. It may seem like a spacewalk is such a big deal that the ISS needs to stop when the astronauts are out there doing their thing, but it's not like that. If the ISS were ever to stop, it would fall straight down to our planet. So, once an astronaut is in a stable orbit, they stay in that orbit, unless some new force acts out. The first spacewalk wasn't as simple as those done later. It was performed in 1965, and it lasted 12 minutes. 2 men set out on a mission. One of them was supposed to float in space for a while taking pictures. But things went wrong. His spacesuit expanded too much, making it hard to move. He started to feel overheated, so he had to let some oxygen out of his suit, which was very risky. He could run out of air or get sick like a deep-sea diver. Getting back into the spacecraft was tough as well, but he somehow managed to do it. Then, more problems came. The spacecraft started spinning, oxygen levels rose dangerously, and there was a risk of an explosion. After a lot of struggle, they made it back to Earth, but landed in a random forest surrounded by wolves and bears during a snowstorm. It took a rescue party to find them. Not a very encouraging story to listen to while you're waiting to go out. But cheer up, things have improved since then. Hundreds of astronauts have taken spacewalks without any serious problems. So here you are, whizzing right along with the giant ISS. Your first spacewalk goes almost flawlessly, so you can enjoy the view a bit. It's hard to control the way you move, but tethers still do their job, so you can focus on your task. Until you realize they failed. How did they untie? You notice you're floating off in some random direction. There's nothing you can hold on to. Your body is weightless, and it has started to spin around. It's so frustrating when you can't take control of your movements. An astronaut named Scott Kelly described this unpleasant feeling in his book Endurance. He was turning around and upside down in the darkness and could see nothing but what was right there in front of his face. It was like a scuba diver floating in murky waters, totally disoriented, with no way of telling which direction was wrong and which one could be right. In space, you can't kick or flail to change your course. It might be fun floating inside a spacecraft with zero gravity, playing and fooling around, but seeing just the endless void filled with stars in the distance and knowing what could happen makes it frightening. And now you're getting closer to Earth's atmosphere. It might seem like the safest option because it makes you feel like you're going home, but in reality, you better hope you'll change direction. If your angle and speed are wrong, you might re-enter the planet's atmosphere and burn up. Not a good deal. NASA trains astronauts for such situations, so you know what's your next step: activating an emergency jetpack called SAFER. This tool is designed to help you stabilize and move in space. You don't even need the tethers. You can control the movements of your jetpack with a small joystick. Finally, all those hours of playing video games will pay off. These jetpacks became an inevitable part of the spacewalk package almost 30 years ago. So far, no astronaut has had to use one during a spacewalk. Whew! You're back on track, and you're moving away from Earth's atmosphere. You're getting closer to the ISS, flying manually. Oops! These jetpacks have one big flaw. They have a limited amount of fuel, and your SAFER has just run out of it. Okay, take a deep breath. One of the most important things every astronaut has to learn is to be prepared for literally anything. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that yes, and these signals aren't anything new. They'd been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. Over billions of years, the surface of the Moon has been hit by asteroids and comets, causing bits and pieces to constantly break off from the impacts. Because of this, all the surface material is pretty loosely packed. So when there are quakes, slopes in the same area can become susceptible to landslides or new faults opening up. Future settlements located too close to these unstable slopes could put everyone living inside these lunar bases at risk. Moon dust adds another layer of complexity because, without erosion or water to smooth it out, it can harden to the point of being as tough as glass. If we really want to understand how dangerous moonquakes might be for people living and working on the Moon in the future, space agencies still need to map out and get new seismic data, and not just from the South Pole, but from the entire satellite. In 2025, the Farside Seismic Sweep Mission, or FSS, plans to deploy two of the most high-precision seismometers ever built to the Schrödinger crater, which is located on the dark side of the Moon. Finding out what's happening on the ground there is crucial for understanding the complex lunar structure and its internal dynamics. Scientists are still trying to figure out whether the lack of recorded seismic activity on the far side of the Moon is due to current instruments not being capable of detecting it, or if it's due to some kind of interference from melted material in the mantle. Once they have this answer, it will be easier to fully understand the phenomenon of shallow moonquakes and assess their implications for future neighborhoods on our natural satellite. Now, you may have heard that Earth is also shrinking, but it's a different process. Basically, the Moon is getting smaller mainly because its core is cooling down naturally. The Earth's core is cooling too, but our planet got its crust with tectonic plates, unlike the Moon, which only has one plate. So the energy from Earth's core shifts those plates around or comes through volcanic eruptions. Earth is actually losing mass overall due to atmospheric loss. Our planet loses about 100 million pounds of mass per year, mostly from a leaky atmosphere. Earth's gravity isn't strong enough to retain the lightest particles, like hydrogen and helium, which escape into space. But don't worry, these numbers aren't cause for alarm, considering that our planet's atmosphere weighs about 5 quadrillion tons, a number I can't even imagine. So, in other words, it would take many, many, many times the current age of the universe for it to completely evaporate. We found a water cloud in space around a black hole. It's a gigantic water reservoir that's located about 12 billion light-years away from Earth. This must be the largest and farthest water reservoir ever detected in the universe. This one cloud contains an astonishing 140 trillion times more water than all of Earth's oceans combined. That's wet. The water surrounds a quasar, which is basically an incredibly energetic supermassive black hole. This quasar is about 20 billion times larger than the Sun and emits as much energy as 1,000 trillion suns. You do the math. As the black hole slowly consumes everything around it, it releases energy. This energy heats the surrounding gases and dust, causing the formation of water vapor. As a result, the black hole is surrounded by a huge water cloud and all the other gases and dust bath around it. This pair formed when the universe was only 1.6 billion years old, just a fraction of its current age. That means that the water isn't young at all and has been existing in galaxies for billions of years now. This quasar will only keep getting scarier and bigger. If it eats up all this gas and dust around, it could grow up to 6 times its current size, potentially becoming 120 billion times larger than the Sun. Think about that. Now imagine a place where a single day lasts longer than a whole year. On Venus, a day, meaning one full spin on its axis, is as long as 243 Earth days. And what's even weirder, Despite the fact that Venus is experiencing a never-ending day, it has a shorter year than Earth. While Earth takes about 365 days to complete one orbit around the Sun, Venus does it in just 225 days. So, somehow, for Venus, a day is more epic than a whole year. Venus is a strange planet in general. It's called Earth's twin because of how alike we are, although it's a bit smaller than Earth. But there are some drastic differences too. For example, it spins in the opposite direction, which means the Sun there rises in the west and sets in the east. And Venus isn't the only one who dances to its own rhythm. Uranus does that too. And finally, Venus is quite crazy in terms of its atmosphere. When you stand on Earth, you don't really feel the weight of the air around you. Well, on Venus, that feeling would be like having an elephant sitting on your shoulders. Venus has 90 times the atmospheric pressure of Earth. The atmosphere there is a thick layer of toxic gases. For example, carbon dioxide that's released by all the volcanoes. It presses down with incredible force. This results in very hot temperatures. No wonder it'll take a long time before we'll be able to stand on this planet. Meanwhile, Mercury, the closest planet to the Sun, has an even more speedy orbit than Venus. It completes a full journey around the Sun in just about 88 Earth days. However, it has a slow spin on its axis, which means that one day on Mercury takes about 176 Earth days, basically half a year. Just like with Venus, a day there takes much longer than a year. Since it's closest to the Sun, no wonder Mercury experiences some super extreme temperature swings. Daytime temperatures can soar up to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But wait for the sunset. At night, it drops to freezing minus 290 degrees Fahrenheit. Ooh! That's because Mercury doesn't have a thick atmosphere like we do, so the heat doesn't distribute across the planet evenly. If one side is in the dark, it'll be super cold, and the other side will be scorching hot, just like if you let a regular big rock lie down under the sun for a while. In fact, it's so cold that there might even be some ice on it. Look at the planet's North Polar region, especially those sunlit yellow spots inside craters. These are indications of water ice. Turns out water is much more common in space than we thought. Mars is often dubbed the Red Planet. It earns this nickname from the abundance of iron oxide, or rust, covering its surface. The iron-rich minerals create a rusty red hue that paints the Martian landscape. But it turns out Mars isn't just red. If you were standing on Mars, you'd witness desert-like butterscotch terrain with caramel and golden glows, some brown, and even a glimpse of a slight greenish hue. Mars also has the biggest mountain in the entire solar system, Olympus Mons, standing at a staggering height of about 13.6 miles tall. It's even taller than Mount Everest. It was formed by the volcanic eruption yielding low-viscosity lava, creating a shield-like structure. Since Mars is covered in sand, it's also famous for its crazy dust storms. But it turns out they're even more insane than we thought. These storms can last for months. While they might present challenges for future human missions, they also contribute to the planet's mesmerizing appearance when observed from afar. And not only storms, but even its own Mars quakes. Also known as seismic tremors, they were first detected by NASA in 2019. Unlike earthquakes that are often triggered by tectonic plate movements, Martian quakes are thought to result from the cooling and contracting of the planet's interior. It's interesting how similar, yet how different the planets are. Saturn's iconic rings might hold a secret link to Earth's ancient past. The rings are composed mainly of ice particles and debris and are estimated to be relatively young in space terms, perhaps just a few 100 million years old. Now, there are some theories that propose that they were born after some catastrophic event. For example, the collision of two large moons or the breakup of a comet. What's interesting is that this timeline coincides with the age of the dinosaurs' demise on Earth. Could there be a connection? Who knows? By the way, while Saturn takes the crown for its rings, it's not the only planet in our solar system sporting them. Jupiter, Uranus, and Neptune all have their own set of rings, although they might not be as visible and cool as Saturn's. However, there's something where Saturn truly stands out: the magnificent hexagon at its North Pole. It's a colossal six-sided figure. Each side of this incredible structure measures around 9,000 miles long, which is 1,200 miles longer than the Earth's diameter. Scientists aren't sure how it was formed or why. They think it might be due to varying wind speeds, or maybe it's shaped by a localized, slow, meandering jet stream. So far, it remains another of Saturn's mysteries. Much like Saturn's hexagon, Jupiter also has its own weird spot. It's called the Great Red Spot. This is a storm that's been raging for at least 350 years and is larger than Earth itself. Despite its name, the spot's coloration has varied over the years, ranging from brick red to pale salmon. Scientists continue to study this enduring storm, unlocking the mysteries of its persistence and ever-changing hues. Meteorologically, the Great Red Spot is a powerhouse. It generates enormous pressure in Jupiter's southern hemisphere. Meanwhile, Jupiter itself is a powerhouse when it comes to magnetic fields. Its magnetic influence is colossal. It extends far beyond the planet itself and creates one of the largest and strongest magnetic fields in our solar system. Because of that, Jupiter is a source of intense radiation and mesmerizing auroras. While Earth's northern lights are breathtaking, Jupiter has something to offer too. The magnetic field interacts with charged particles from Jupiter's moons and the solar wind. This creates visually striking auroras near its poles. But compared to Earth, the scale of these auroras is incredible, like nothing we've seen on our planet. But even having a cool big spot isn't a unique feature in our solar system. A stormy giant Neptune, the eighth and farthest planet from the Sun, also has its great dark spot. Just like Jupiter, it's a massive vortex in Neptune's atmosphere. But unlike its Jupiter counterpart, this spot tends to come and go because of Neptune's dynamic and ever-changing weather patterns. Neptune, together with Uranus, is known as an ice giant. And just like other giants, it boasts some of the most ferocious winds in our solar system. Its supersonic winds can get faster than 2,200 miles per hour. What a drama queen! But this explains its thick cloud formations. By the way, if you ever dreamed of a planet raining diamonds, you might want to visit this planet. Deep within Neptune's atmosphere, where pressures are extreme, scientists theorize that carbon atoms are compressed and form diamonds. And then, these diamonds might be raining down. What a unique touch to stormy weather. Neptune's moons got from their parent with the weird weather. For example, its largest moon, Triton, has a touch of cryovolcanism. Instead of spewing molten rock like Earth's volcanoes, Triton's cryovolcanoes erupt with a mix of water, ammonia, and nitrogen. Picture it as icy geysers shooting material into space. Seems like in our solar system alone, each planet has its own quirks and interesting qualities. Let's hope that we discover some more interesting things in outer space in the future.
About a third of all grown-ups have a snake phobia. But if you decide to become an astronaut not to have to deal with them, it might not be a great idea. According to Story Musgrave, there are snakes in space. Musgrave is one of the most experienced astronauts in the world right now. He is the second astronaut who managed to go on 6 space flights and fly on all the space shuttles. With that much experience and time in space, he has to have 1 or 2 space horror stories in his career. Once on a space mission, he looked out of the window and saw something resembling a snake. Musgrave said it was 6 to 8 feet long and looked like a snake. But many people don't believe his story. They claim it was some trash floating in space or something that had detached from the spacecraft. But the astronaut went on another mission and saw the creature again. The first time he spotted it, it could be some detached piece from the spacecraft. But what are the chances of that happening twice? He gave many interviews in which he explained these crazy encounters. Let's hope those snakes stay in space and don't come crashing down on Earth. If they are real, of course. Snake rain would not be fun. As we all know, space is like a giant vacuum chamber with zero air, and sound can't travel there, making this story even more terrifying. To communicate, astronauts have a special system in their suits to exchange information. young Li Wei shared his terrifying experience, and it's hard to believe it actually happened. You would be terrified if you were alone at home and someone started knocking on your door at night. Of course, if you weren't expecting anyone. Imagine the same scenario, but you're in space. You hear some knocking, you have nowhere to run, you're trapped in a metal can floating into nothingness. Young was sitting in his spacecraft, minding his own business, when he suddenly heard knocking coming from outside. How is it possible? Sound can't travel in space. The noise was unique. The astronaut described it as if someone had been knocking on an iron bucket with a wooden hammer. Li Wei looked outside, but to his surprise, there was nothing there. He investigated a bit more, but couldn't find the source of the sound. When Young returned to Earth, he was eager to tell scientists about what had happened, but he could not recreate the sound. To add fuel to the fire, his colleagues, who were on the same mission from 2005 to 2008, said they had also heard knocking similar to what Young had reported. This is still a mystery. Nobody knows what happened then. Maybe it was just spacecraft noise, like those your house randomly makes. We've already mentioned that sound can't travel in space, but that doesn't stop weird noises. The Apollo 10 mission was one of the most significant space missions ever. So, astronauts had to ensure everything was perfect before they went on a moon exploration journey. 3 people were on that mission: Thomas Stafford, module pilot John Young, and lunar module pilot Eugene Cernan. They had to do tons of gear tests for the upcoming Apollo 11 missions. The astronauts were circling the moon when they heard music coming from somewhere. It wasn't like Ed Sheeran's concert, it was more like constant loud screaming. Then, it was quiet whistling. They were terrified. Imagine being in space for the first time and hearing weird noises. The sounds lasted for a whole hour. The astronauts had never heard anything like that before. The sound was otherworldly and creepy. When they returned to Earth, they didn't know if they should tell someone about their experience because it was hard to believe. Michael Collins, an astronaut from the Apollo 11 mission, later shared that he had also heard this sound. But there is a kind of logical explanation for this. Engineers from NASA said that the sound that they had heard had been caused by the interference with the communication system. So you can relax and throw your tinfoil hat in the trash. But before you do that, Al Worden, an astronaut from the Apollo 15 mission, said that this explanation was unlikely, so we might never find out what really caused the sound. Leroy Chiao was the commander of the International Space Station in 2005. When it comes to space, he's seen a lot of things that can send chills down your spine. One encounter he and his crew had will live on in their head rent-free forever. Chow was sitting in the space station doing his job when he suddenly spotted light from the corner of his eye. He took a closer look, and it resembled an upside-down V, floating and glowing in space. Leroy later explained that he hadn't been scared by the object. Quite the opposite. He was extremely excited to see it, even though he had no idea what it was. His crew also saw the strange object. Chow was convinced he was visited by something not from Earth. His team could also vouch that indeed they saw something unexplainable. The information about this encounter is all over the internet, and many people are skeptical. It could have been anything. There are more than 10,000 satellites in space right now. It could have been a satellite floating in space. Another theory is that those were lights reflecting from a fishing boat on Earth. But who knows? There may be another logical explanation for this phenomenon waiting to be discovered. Horror stories don't stop there. This one is hard to believe, and it's up to you to figure out if it's true. Astronaut Alan Bean was the 4th individual to set foot on the moon's surface. When he was on the Apollo 12 mission, he claimed he saw a unique shape on the moon. It was shiny and shaped like a shoe. It's hard to know what he saw because he passed away in 2018. Chinese lunar rover Yutu-2 also discovered some shiny substance on the moon. Scientists say it was something gel-like. It could be a glaze that formed when something impacted the moon's surface, like a meteorite or something else. But in the future, we might find a better explanation for this strange find. This may sound wicked, but many countries send animals to space before humans follow them. Take Miss Baker, a squirrel monkey, Ham the chimp, and many more. Many of these animals returned to Earth safely and lived happily ever after, like Ham the chimp, that lived for 26 years. But some weren't so lucky. Astronauts are still creeped out when they see animals floating in space. Imagine seeing something like that in a dark vacuum. No matter how tough you are, after that, you will be afraid of your own shadow. This may be sad, but it was an essential step in space exploration. The following horror story comes from space engineer Musa Manarov. This guy came across something that made scientists confused. He was shooting a video of space when he accidentally filmed some shiny object flying in the distance. The thing had a cylindrical shape, and Manarov thought it was something that had detached from the spacecraft. But he was unsure because it moved in a unique way. When you think of a creepy space story, the first thing that comes to your mind is some creature crawling on the spacecraft, or some weird object flying in space. But all those things are highly unlikely to happen. When somebody asked Chris Hadfield what the scariest thing about space was, he said it was asteroids. There are thousands of them in space, and the spacecraft is constantly getting hit by them. Chris said that he'd always heard sounds from asteroids hitting his spacecraft. He also mentioned that the spacecraft's solar panels were covered with holes. And you never know whether a giant asteroid will come and hit your spacecraft.
Just watching certain scenes from the movie Gravity was scary, let alone imagining what would happen if you really ended up in the cold, endless void called space without knowing if you'd be able to go back. But let's say you're really up there. You're so excited about your first spacewalk. It sounds risky, but it's something astronauts on the International Space Station do quite often. It's easy to understand why accidents at work are way scarier up there than some regular 9-to-5 job on Earth. But that's why you have more training and special equipment to keep you safe. First, astronauts are always attached to the spacecraft with tethers, so they don't float away like a helium balloon. It may seem like a spacewalk is such a big deal that the ISS needs to stop when the astronauts are out there doing their thing, but it's not like that. If the ISS were ever to stop, it would fall straight down to our planet. So, once an astronaut is in a stable orbit, they stay in that orbit, unless some new force acts out. The first spacewalk wasn't as simple as those done later. It was performed in 1965, and it lasted 12 minutes. 2 men set out on a mission. One of them was supposed to float in space for a while taking pictures. But things went wrong. His spacesuit expanded too much, making it hard to move. He started to feel overheated, so he had to let some oxygen out of his suit, which was very risky. He could run out of air or get sick like a deep-sea diver. Getting back into the spacecraft was tough as well, but he somehow managed to do it. Then, more problems came. The spacecraft started spinning, oxygen levels rose dangerously, and there was a risk of an explosion. After a lot of struggle, they made it back to Earth, but landed in a random forest surrounded by wolves and bears during a snowstorm. It took a rescue party to find them. Not a very encouraging story to listen to while you're waiting to go out. But cheer up, things have improved since then. Hundreds of astronauts have taken spacewalks without any serious problems. So here you are, whizzing right along with the giant ISS. Your first spacewalk goes almost flawlessly, so you can enjoy the view a bit. It's hard to control the way you move, but tethers still do their job, so you can focus on your task. Until you realize they failed. How did they untie? You notice you're floating off in some random direction. There's nothing you can hold on to. Your body is weightless, and it has started to spin around. It's so frustrating when you can't take control of your movements. An astronaut named Scott Kelly described this unpleasant feeling in his book Endurance. He was turning around and upside down in the darkness and could see nothing but what was right there in front of his face. It was like a scuba diver floating in murky waters, totally disoriented, with no way of telling which direction was wrong and which one could be right. In space, you can't kick or flail to change your course. It might be fun floating inside a spacecraft with zero gravity, playing and fooling around, but seeing just the endless void filled with stars in the distance and knowing what could happen makes it frightening. And now you're getting closer to Earth's atmosphere. It might seem like the safest option because it makes you feel like you're going home, but in reality, you better hope you'll change direction. If your angle and speed are wrong, you might re-enter the planet's atmosphere and burn up. Not a good deal. NASA trains astronauts for such situations, so you know what's your next step: activating an emergency jetpack called SAFER. This tool is designed to help you stabilize and move in space. You don't even need the tethers. You can control the movements of your jetpack with a small joystick. Finally, all those hours of playing video games will pay off. These jetpacks became an inevitable part of the spacewalk package almost 30 years ago. So far, no astronaut has had to use one during a spacewalk. Whew! You're back on track, and you're moving away from Earth's atmosphere. You're getting closer to the ISS, flying manually. Oops! These jetpacks have one big flaw. They have a limited amount of fuel, and your SAFER has just run out of it. Okay, take a deep breath. One of the most important things every astronaut has to learn is to be prepared for literally anything. That's why they go through pretty intense training sessions, so they can remain calm even in very stressful situations. A long time ago, NASA would choose astronauts from test pilots who went through harsh training in the jungles of the Philippines without any help, so no instructions or supplies. Later, they implemented a special training regime with outdoor exercises in different climate environments and even underwater to simulate conditions in space. Today, astronauts are trained to work in teams to stay focused and calm while handling difficult tasks. For instance, when they needed to fix the Hubble telescope, astronauts had to work for more than 8 hours in the harsh conditions of space to remove a broken part. It was a frustrating task. Plus, the gloves they had to wear made things harder, but they still did it. They also train in a giant water pool in Houston, which is a pretty good replica for the ISS. That's where they practice spacewalks and try to repair things while being underwater all the time. The water makes them feel weightless, while their suits are heavy enough to mimic the effects they could experience during spacewalks. You also need to have sessions with aerospace psychologists. They help astronauts handle stress and stay mentally strong. They check astronauts before, during, and after missions, helping pick the best candidates for spacewalks. Not everyone can go through these harsh conditions. Out of 16, only 10 get chosen. Even though so many safety measures are taken, space is still an unpredictable place where we don't have as much power as we'd like to. Back in 1973, during a spacewalk on the Skylab space station, 2 astronauts were in a very risky situation. They were out in space fixing things, but they didn't have the same handy jetpacks like astronauts do today. They could only rely on safety tethers. Suddenly, the solar arrays they were working on moved unexpectedly and pushed them out of their position, almost sending them drifting off into space. Thankfully, the safety ropes did their job. Strong, resistant to heat, and attached to astronauts' waists, these tethers can hold a weight of about 881 pounds. This accident happened before SAFER came into use. When up in space, a lot of things can go wrong, and sometimes even astronauts' training and equipment can't help solve the problem. That's where the Mission Control Center on Earth jumps in. Thousands of people work on Earth to support the astronauts on the ISS. But if the communication system doesn't work, or no one's close enough to help, that's where the rescue operation stops. You just continue to move in a random direction, waiting for the 7.5 hours of air you have to run out. Feeling hungry? Unfortunately, you can get nothing but some water you have in your helmet. Maybe you'd stop spinning at some point. The view would be fascinating. You could watch the Earth rise and set about 5 times, depending on where you are. And while you'd be getting farther away, and Earth would be turning into a small dot lost among asteroids, stars, and space debris, a random picture would come to your mind. A stunning sunset at the beach, the sound of waves, and your favorite pizza. Now, it's so far, it almost seems like part of another dimension.
We often see humans living on other planets like Mars. Colonizing our solar system and beyond has long been a dream of humankind. The idea of humans going to space dates back to at least 1610. A German astronomer named Johannes Kepler wrote to an Italian astronomer named Galileo. Kepler said that we could create ships to travel in space, and even create maps of the stars. People got more excited about space during the famous space race. NASA was created in the 50s. They did many cool things, like sending space stations, Mars rovers, and exploring other planets. All this made space travel seem more real. Today, we've developed to the point where we finally discuss the possibility of space tourism. We're already sending regular people into space. Only very rich people, of course. But many believe that, in just a few decades, space tourism will become normal. We'll be able to fly to Earth's orbit and back, as if on some kind of tour. Spaceships will replace airplanes, and it will only take 2 hours to get from Australia to England. And finally, we'll begin to travel to other planets in our solar system. Some scientists even believe we'll have colonies on the Moon or Mars by the 2060s. In the future, we could colonize not only Mars, but some of the moons, like our own, Ceres, Titan, and others. But the thing is, why do we even want to live on other planets? Surprising question, huh? Sure, the answer might seem obvious at first glance. Humans want to learn about space and other planets. This curiosity is what led us to other big discoveries like going to the Antarctic and the Moon. Next, safety, of course. Humans have a moral duty to ensure our survival. Colonizing space could protect us from disasters that might wipe out life on Earth. Plus, by settling space, we improve our chances of survival and fulfill a moral obligation to do so. Besides, with Earth's overpopulation, colonizing other planets could relieve the strain on our home planet. Another thing is, colonizing a planet means living there and using its resources. And let me tell you, there are lots of resources in space. Our solar system alone has things to use for fuel, like Titan. Space colonization could bring us clean energy, access to new materials, new technologies, and so on. The more we colonize space and learn about it, the more we could benefit humanity. More technology, more exploration, more innovation, and so on. History also says explorers are way less likely to get into fights. Expanding and exploring, scientists claim, keeps us busy with cool discoveries, growth, and research. The more we explore, the less we're stuck with our earthly problems. But on the other hand, not everyone is interested in going to space. And maybe colonizing space isn't as good an idea as it seems. First of all, is it even possible? Some people say that living in space is just too far-fetched. You might have heard about terraforming. Terraforming basically means changing and improving the planet however we want, as if we were in some character maker in a video game. Sounds great. In theory. In reality, terraforming Mars, for example, could take hundreds of years and cost millions of dollars, according to experts. Colonizing our moon could cost an unimaginable $104 billion. It's 7 times NASA's yearly budget. And that's not even counting the earthly costs. But the biggest, most important question is it really that cool to live in space, though? Space isn't your cozy home at all. Most celestial bodies are radiation hotspots, all because of the solar winds. Imagine a wind so fierce that it can strip planets of their very atmospheres. Our sun is a real danger to each planet in the system. Yes, including our own Earth. Stars are crazy powerful. They shoot out charged particles all the time. These particles can zoom around at incredible speeds, going up to 5 million miles per hour. These gusts of particles can leave an entire planet all barren. Poof. No more life-sustaining air. The water on the planet would evaporate, then freeze. The temperature would plummet to very chilling. And even daytime skies would be as black as night. Lucky for us, Earth has an amazing shield called a magnetosphere. It protects us from these space winds. But scientists are studying these winds to help us find other friendly planets out there. By checking out stars' properties, gravity, and magnetic fields, we can see if their planets can truly host life. And it's very hard to find a planet that isn't showered by radiation all the time. It has to have a very thick atmosphere, like on Earth, to prevent this from happening. Unfortunately, we haven't discovered any planets like this so far, which is why living in space would mean dealing with crazy health problems. Temperatures and radiation are just the beginning. What about muscle loss? Troubles with vision and many other things. Humans are way too vulnerable for that. Robots are more suited for space exploration due to its hostile conditions. Let's take Mars, for example. The red planet is freezing and very uninviting. In fact, the Earth could face almost anything, even mega problems, and still be better than Mars. Mars is a desert with barely any water, very far from the idea of a dream home. Let's imagine that the Earth's air get polluted. Mars still wouldn't be better. The air there is super thin and 96% carbon dioxide. Earth's air is a cakewalk compared to that. Or even if a huge asteroid crashes into Earth, we're still better off here than on other planets. It might even be a pretty big asteroid, like the one that wiped off the dinosaurs. This event was absolutely catastrophic, plunging the Earth into utter chaos. It created a massive crater called the Chicxulub crater. The impact led to massive fires, tsunamis, and a lot of dust and debris flying into the sky. The dust and debris blocked out the sun for a long time. Can you imagine what happens when there's no sunlight at all for a while? Everything got really cold and dark. This darkness and coldness affected plants and animals. Without sunlight, plants couldn't make food through photosynthesis, and that meant many animals lost their source of food. And these were only short-term consequences. Of course, many species became extinct because of that, but even with all that, 25% of species managed to survive somehow. If this same asteroid had hit Mars, the outcome would have been much worse. Mars doesn't have enough things like water and air to support life like Earth does, so the consequences would be way harsher. Actually, the Earth survived not 1, but 5 mass extinctions. And life still managed to thrive on our planet, even after all that. As you can see, it's almost impossible to make the Earth completely inhabitable. Our planet will always be the most habitable place compared to anywhere else in our solar system, unless we do something extremely insane. Which is why we need to protect it. Here we come to the famous "the Earth's in trouble" argument. If something bad happens to our planet, why not focus on fixing it instead of flying away? Critics argue that if we can't take care of Earth, we shouldn't spread our problems to other planets or moons. Are we really capable of responsibly colonizing other worlds if we can't even manage our own? Plus, there's still so much to explore even on our own planet. Humans haven't even lived in Antarctica or under Earth's oceans yet. Are we sure we're ready for worlds that are even more extreme than that? So, even if Earth gets into trouble, we shouldn't just ditch it. We have to work together and create safe zones. It would be a big challenge, sure, but it's still way more doable and cheaper than building space colonies. Of course, the idea of humans living in space and traveling to other planets is very exciting, but we should never forget our sweet home, and we should remember that life isn't science fiction. We should use our technology rationally and focus on making the Earth safer and better. And what do you think about it?
Picture this. You're floating about in the depths of space, gazing down on our blue marble of a planet. What's on top? You might think it's the North Pole, but that isn't necessarily so. The truth is, our collective belief that the North is at the top of the world doesn't have any solid scientific backing. It's just one of those things we've accepted over time. And this acceptance has a compelling history, with a dash of astrophysics, a bit of psychology, and a surprising twist. It influences how we feel about our world more than we might think. Figuring out where you are is crucial for survival, and that's true for most species, not just us humans. Similar to honeybees, for example, humans have a knack for creating mental maps of our surroundings. But where we really stand out is in our efforts to share these maps with others. We've been at it for a while now, drawing maps on anything from cave walls to computer screens. The earliest ones we've found date back to 14,000 years ago. Despite this long history, it's only in the last few centuries that we've decided that the North should consistently be at the top of the map. History buffs tell us that for a long time, the North was hardly ever at the top because it symbolized darkness. The West didn't make the cut either, given that's where the sun bows out each evening. However, early Asian maps seem to defy this trend. Now, before you say it, their compasses weren't the reason they put North at the top. Early Asian compasses were actually aligned to point south, seen as a more favorable direction than the cold, dark north. But in these maps, the emperor, who resided up north, was always placed at the top, with his loyal subjects gazing upwards towards him. Looking back, every culture had its own idea of what was worth looking up to, leading to varied orientations of early maps. The Egyptians preferred the east, where the sun graces us each morning. Early Arabic maps favored the south. European maps from the same era put the east at the top. So, when did everyone decide that north was the new top? You might be tempted to credit it to explorers like Columbus and Magellan who navigated by the North Star, but they didn't really see the world in that light. Columbus, for instance, saw the world with the east at the top, believing he was headed toward paradise. Mercator's 1569 world map was a game changer, considering it was the first to factor in the Earth's switch to more accurate navigation. But even then, the emphasis wasn't on the north. Mercator projected the poles to infinity, considering them relatively unimportant as sailors didn't venture there often. It's possible that the choice to place north on top was simply because the Europeans, who were doing their fair share of exploring, were located in the northern hemisphere with a whole lot more land to cover and people to meet. For whatever reason, this north-up idea has stuck. Even when a NASA astronaut in 1972 snapped a photo of the Earth with the south at the top, it was flipped over to avoid confusion. Here's where it gets interesting. When you gaze at Earth from space, the concept of up and down loses all sense. Sure, Earth aligns with the plane of other planets in our solar system because we all share a cosmic birth story, but we could just as well flip the image or put the sun on top or bottom depending on your cosmic viewpoint. Even within the Milky Way, our solar system is tilted by about 63 degrees. If you think about it, the concepts of up, down, left, or right don't really apply in space. But how about a change of pace? Should we be open to viewing our world from a different perspective? There's some psychological evidence that our north-up mentality might be skewing our perceptions of value. Most folks consider the north to be up and the south down. It even made psychologists wonder if these associations might influence how people value different places on a map. When shown a map of a made-up city, people were more likely to choose a residence in the northern part. And when asked where hypothetical people of different social status would live, they allocated the rich to the north and the less fortunate to the south. It's not too big of a leap to speculate that humans might be less bothered about what happens to regions lower than where they are on the map. But there's a simple solution: flip the map upside down. These experiments showed that this simple action wiped out the north equals good bias. On that note, south-up maps are already available online. Australians would enjoy this change, that's for sure. Whatever it is that you'd prefer at the top of your map, you would need a compass to guide you. Have you ever paused to think of its system? It is one of the oldest gadgets we've got in our survival toolkit. It's been around for centuries, serving as a beacon for adventurers, travelers, and explorers, guiding them through uncharted oceans and helping them discover new continents. Basically, compasses turned humans from stay-at-home types into globe-trotting nomads. Our beautiful blue planet isn't just a spinning ball in the cosmos. It also has its own magnetic field. Imagine it as a colossal magnet, humming with invisible energy. This is all thanks to Earth's core, a ball of molten iron under terrific pressure right at the center of our planet. This core, part liquid, part solid crystal, churns and swirls due to Earth's spin, creating the magnetic field that gives us our north and south poles. But here's where it gets a bit complicated. These magnetic poles don't perfectly line up with the Earth's geographic poles, the ones that the Earth spins around. They're close, sure, but not exactly in the same place. This is why the compass, which reacts to magnetic fields, doesn't point directly to what we call true north, which is the geographic North Pole. Instead, it points to the magnetic north, located a bit off from the true one. But don't worry, it's close enough to get us where we need to go. Let's talk more about this true north versus magnetic north business. Remember the piece of news from September 2019, when for the first time in over 360 years, compasses at Greenwich pointed to the true north? Well, that's quite a rare occurrence. Usually compasses point towards magnetic north, which isn't a constant spot on the map. It changes and drifts over time, following shifts in the Earth's core. On the other hand, true north refers to the geographic North Pole, a specific unchanging point on Earth's surface. So when you're holding a compass, it's really the magnetic north it's directing you toward, not the true north. Here's where things get even more fun. The angle between the direction of the true north and the magnetic north, as shown by the compass, is called declination. It's a fancy word for a simple concept. Now, because Earth's magnetic field isn't a simple, straightforward thing, it has its wobbles and dips. The declination isn't the same everywhere. It varies from place to place. Also, here's what it's made of. It has this tiny needle that's made from a metal that's been magnetized. Iron's a common one. They set this needle on a little pointy thing, or pivot, and let it float in some kind of liquid. Often, it's mineral oil, or something similar. This lets the needle spin around and dance with the Earth's magnetic field. When you hold your compass flat in your hand, the needle settles down and points to magnetic north. Now, look at your compass and you'll notice these small markings. They're known as degrees, and here's the fun bit. The needle's red end always points north, and the white or black end always points south. That's your compass's north-south dance. Plus, there's often an arrow on the compass case, right at the top. That's your orientation arrow.
For decades now, people have been dreaming of exploring space. And since the year 2000, there has indeed been a continuous presence of people in space. And recently, a new record has been set. Just a couple of weeks ago, there were 17 people from 5 different countries in Earth's orbit at the same time. The previous record was set in September 2021 during the privately funded Inspiration 4 mission. At that time, the number of people in orbit reached 14. So let's see. Just recently, 3 more people have arrived at China's Tiangong space station. There were 3 more astronauts aboard the same station, but they've been there since November 2022 and are supposed to return back to Earth in June. Then there are 7 people on board the International Space Station, and 4 more departed the ISS aboard SpaceX's Crew Dragon named Freedom. They successfully returned to Earth on the 30th of May 2023, leaving 13 people in orbit. Interestingly, the current record also includes the 600th person to get into Earth's orbit. Specialist Rayana Barnai from AX-2 mission became a space traveler number 600, as well as the first Saudi woman in space. But I've got something even more exciting to tell you. Oh my! The record for most people in space, and just not in Earth's orbit, was reset not so long ago too. But it lasted for a mere 5 minutes or so. But during this short period of time, there were 20 people off the planet. This record was set when 6 members of the Virgin Galactic Unity 25 Spaceship Two crew happened to be in space at the same time as 3 Chinese taikonauts living and working aboard Tiangong and 11 astronauts on board the International Space Station. Now, that's getting crowded. Well, the International Space Station has always hosted the majority of space travelers from Earth. But I bet there are some cool facts about this marvel of technological development you haven't heard yet. The ISS is the third brightest object in the night sky, and the coolest thing? You can sign up for a special service and you'll get a text every time the ISS travels over your location and is visible with the unaided eye. I've seen it dozens of times myself, and it's very, very cool. Normally, you can see it between dusk and dawn, but be ready because the station is very fast. It moves at a speed of 5 miles per second and circles our planet every 90 minutes. The International Space Station is a true record breaker. It's the largest human-made object in space. It's 357 feet long from end to end, which is about the same length as a soccer field. It also weighs about 450 tons. 8 spacecraft can dock at the ISS at the same time. The working and living space of the station is bigger than a 6-bedroom house. Astronauts have 6 sleeping quarters, a gym, 2 bathrooms, and a beautiful 360-degree view from their special bay window. Now to the nitty-gritty. On the ISS, you wouldn't have to deal with lots of disgusting smells. There is a specially trained person who smells everything astronauts take with them in space. It's done to protect them from unpleasant odors. The thing is that you can't really air the room out there if you don't like how it smells inside. That's why NASA is very careful about what kinds of smells are allowed to pass through. You'd also have to get rid of your clothes instead of washing them after each use. To bring a mere 1 pound of load to the International Space Station costs up to $10,000. That's why it's easier to throw your clothes away when they get dirty than to waste water washing them. Now, while sleeping, you'd have exceptionally good airflow around you. Otherwise, the carbon dioxide you'd exhale would form a bubble around your head and you get oxygen deprived, and that's not good. Now, people often think that in space you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon can orbit Earth and the Sun doesn't float away from our home Milky Way galaxy. But astronauts on the ISS experience not full-fledged but microgravity, which means itsy-bitsy gravity. Earth's gravity on the space station is not only around 10 to 12% weaker than the gravity on the planet's surface, but astronauts are constantly in free fall. The spacecraft, the people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. But our space exploration plans are much more ambitious than just orbiting our planet on board the ISS. We're planning to send a mission to the Moon and build a colony on Mars. Some experts claim that in the next 25 years, around 20,000 people are likely to leave Earth. But how many people would it take to colonize an entire star system? In 2002, anthropologist John Moore from the University of Florida stated that a spaceship with 150 passengers could leave Earth and set off on a several thousand years journey to another star system. And upon arrival, the descendants of the original crew could build settlements in a new world. That seems like a lot of work to me. Let's continue. The nearest star system, Proxima Centauri, is 4.2 light-years away from our home planet. Talking about space, it's just next door. But for us, it's so far that we would need to build a generational spaceship to get us there. But the question is how many people you'd need to send on such a mission to have enough genetic diversity. A new study disagrees with John Moore, claiming it must be way more than 150 people. According to a scientist from Portland State University, a spaceship traveling to such a distant world would have to carry at least 10,000 people. This number might secure the success of the mission. 40,000 people would be even better. Who knows what could happen to the travelers during such a challenging and unprecedented journey? At the moment, NASA isn't ready to send humans even to Mars, let alone a distant solar system. But a few private organizations are working on this project. They hope to make interstellar trips possible in the next century. They count on a huge increase in propulsion speed, which could potentially reduce the travel time between stars to a mere few hundred years. Researchers have built several simulations to figure out how many various scenarios could play out during such an interstellar mission, and they have come to the conclusion that the success of this mission would greatly depend on the size of the starting population. Genetic diversity would keep the travelers healthy. The larger the population is, the more diversity it has. And 150 people is definitely not enough to maintain genetic variations. Even a population of 500 people wouldn't be sufficient enough. At the same time, if we sent to another solar system 40,000 people, we'd be able to maintain 100% of the variation. Even 10,000 travelers would make the scenario relatively stable, which means that any number between 10 and 40,000 people would be a pretty safe bet. But of course, we wouldn't be able to send so many people in space in just one spaceship. We'd have to build many and spread people among them. These ships could be modular, able to dock together for trade and some social gatherings, for the genetic variety, I'm guessing. But they would travel separately, so that if some disaster struck one of them, the rest would remain unharmed. But to make interstellar travel possible, researchers and engineers will have to overcome loads of obstacles. We still need to increase propulsion speed, deal with the negative health effects of living in space, and invent self-sustaining systems providing air, water, and food. Or we could just decide to fix our own planet and stay home. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or